Hello, everyone, and welcome to Global AI Bootcamp. And of course, this is the Wally channel. And thank you all for coming today and streaming. So first up, we are having Alex from Advancing Analytics, and he is going to be talking about real-time scoring using Azure functions. And of course, if you've got questions, that's perfectly fine. Just use the YouTube commenting section to leave comments and we will answer them at the end. So without further ado, I'm going to introduce you to Alex here. Hello, Alex.
Hi, how you doing?
Very good, thank you. Looking forward to hearing all about this talk. So if you're ready, it is over to you.
Perfect, thank you very much. Hi, I'm Alex. I'm a data science consultant and general machine learning operations enthusiast. I'm based in Lincolnshire in the UK, which is a very nice part of the East Midlands. I live with my cat, who loves to interrupt me whenever I'm on webcam. So if she shows up, don't be alarmed. So in terms of my background, I have a background in computer science. I've been doing machine learning engineering for a little bit over 5 years. I've worked on a range of different projects, from sports wearables, kind of designing algorithms for fall detection using data from gyroscopes and accelerometers. I've worked on agricultural projects, trying to detect and size vegetables in real time as they're being harvested. And I've also worked with insurance clients looking at fraud modeling and things like that. Although it's quite a wide range of different projects, one thing I have noticed is that the challenges they face are fairly much all the same across the board. So the sort of things I'm going to speak about today and that I'd like to cover is a very brief look into the MLOps lifecycle, which just expands a little bit on the process of taking a machine learning model, training it, bringing it into production, and making sure that the model is constantly providing the best results possible. And then I'm going to focus a little bit more specifically on deployment. What types of deployment are there? What is real-time deployment? What is batch deployment? And some of the methods that we can do and some of the use cases for those. Next, I'm going to talk about Azure Functions, which is one of my favorite ways to deploy machine learning models. And then I'm going to give a brief demo and an explanation of a very basic implementation to quickly and easily get your models into deployment. And then I'm going to go through a little bit more of an advanced implementation using a couple of tools like MLflow and Pydantic, just to add another layer of robustness and make sure that your models are going to be the best that they can and provided to the users in the best way possible. So first off, the MLOps lifecycle. So in machine learning, there's more than just a little bit of feature engineering, training a model and going, aha, I can make a prediction, I can do a classification. There's an entire process surrounding that, which kind of adds to the whole picture, which is defined by ChatGPT as a framework for managing end-to-end machine learning, from development processes, data preparation to model deployment and monitoring. So it will kind of cover everything, the entire life cycle from initial concept to deployed model. The life cycle I like to look at has got 6 stages. It's got the explore stage, the evaluate stage, the develop, package, deploy, and monitor. And as a life cycle, they all link to one another. So once you get to the end, the whole thing repeats. I'm going to break down these stages just a little bit for you so you can have a better understanding of what they are. The first stage is the explore stage. This is where data scientists will perform their feature engineering. They will try and test different algorithms and models. They'll do things like hyperparameter tuning, and it's where they're looking at the data, looking at the different models and trying to find something to give the best possible performance, the best accuracy for what they're trying to do. You then have the evaluate stage, which is firstly looking at the actual performances of the models. Is it doing well? Has it got a good accuracy? But also, does it have good precision and recall? But further to just the performance of the model, it's looking as to whether it is actually going to provide value to the business. Is it doing something worthwhile? Is there going to be benefit to continuing with this project and using it for its purpose? Another way MLOps is essential at this stage, pardon me, is by evaluating things like the model's fairness and interpretability. If you're in a highly regulated sector, you can't have a model for kind of classifying, for example, the diabetes of a patient, which doesn't know what it's talking about, because there could be huge ramifications. So it's important to look at, is this model fair? Is it working correctly? Next up, you have the develop stage. So your model's been thoroughly evaluated and you think it's ready for consumer use, but you need to create a robust inference pipeline and make sure that if you're creating a model, it can be easily reproduced, your environment is stable, everything is ready to go, which moves on to the packing stage. The last step before deployment is to ensure that the pipeline is run in the same environment to where it's being trained, so that there's no mismatches between inference and results you're getting while you were training and the results you get where it's deployed. This means knowing the versions of the libraries that you're using and making sure that they're the same in all of the places. This will avoid any versioning errors that might affect the model. And it will also make sure you're able to access the model through external tools such as MLflow or HTO once your model has been deployed. Now we get onto the bit which is my favorite, the really exciting stuff, which is the model deployment, which is taking an artifact or a set of scripts and turning it into something that can actually be used to provide you results. The sort of questions you might ask in the deployment phase are, does it need to be real-time or batch? What sort of load does my model need to be able to handle? Are there going to be thousands of requests a second, or is it going to be once a day, twice a day? I'm not going to answer these now. I'm going to go over them in a little bit more detail shortly, as this is where the presentation will focus. And then finally, you've got the monitor phase. The work doesn't stop once your model has been deployed. All models will eventually degrade over time as data changes. So will the accuracy of the predictions and the trust of your end users. So to avoid this, you'll want to monitor your model for things like data drift, just to make sure that it's always providing the best possible results. And if your drift detection flags up that the model is no longer working properly or the data has changed, this will trigger you to kind of repeat the entire life cycle again. You'll want to go back into the exploration, check your data, train new models, redeploy them, everything like that. But fortunately, there are a lot of tools out there which mean each kind of iteration of the ML lifecycle isn't a huge amount of work each time. You can automate many of the stages. You could even automate the monitoring, triggering, the retraining. You can kind of really speed things up. So if things change, you can easily adapt to it in the future. So you've trained a model. What's next? A very familiar scenario that I've seen is you have a data scientist who goes, I've trained a model, it does this. And they'll get a message on Slack or Teams from someone going, oh, I've got a CSV with some data in. Can you just run the model on this? That is not a model deployment. That's a horrible way to get things wrong. You will end up having different data scientists with different versions of the models, sending the wrong predictions to the wrong people, and it's just going to be a horrible mess. So there are a number of ways that you can look to kind of do your querying, get the results from your models in a much more secure and robust manner. So there are two types of scoring when it comes to getting results from your machine learning models. There is real-time and there is batch. So real-time scoring, as the name suggests, is where you send a query to your model and you would get a response back in real time, normally within a couple of seconds, maybe a minute, depending on the size of the model and the size of the data. But this is normally done on small single packets of data, things like that. And a few use cases for this are things like fraud detection, predictive maintenance systems, and recommendation systems. So for fraud detection, real-time scoring can be used to detect fraudulent transactions each time by scoring it against the model and then flagging any transactions that are deemed fraudulent or declining them. This might be part of an insurance process or online purchases, registering for a bank account, things like that. Next, you have predictive maintenance. So it can be used to predict when equipment will fail by having a machine learning model trained on sensor data and then constantly running that sensor data through the model. And if it detects any sorts of chances of fault, then it can create a flag. You can go and check on your machinery, check on your equipment, and make sure that you adapt and you don't have any breakdown of machinery, which could hamper whatever process you have, whether it's like a packaging factory or whether it's on farm machinery or IoT devices, things like that. And finally, personalized recommender systems. Real-time scoring can be used to personalize content and make real-time recommendations based on user behavior, whether this be Netflix recommending you things to watch or Amazon telling you which books you might like based on things. If you watch a couple of shows on Netflix, then you have to wait a week for the next batch of recommendations to be made. That's just, it's not fun, it's not interactive. It's another great case for real-time scoring. Finally, you have batch scoring, which is where you would wait, you would build up a much larger pool of data, and then you would run it all through the model in a single batch. Again, another self-explanatory name. Use cases for this might be things like churn prediction, credit risk analysis, and forecasting. In churn prediction, batch scoring can be used to predict customer churn by scoring customer data periodically and flagging any customers who are at risk of leaving. It's not something you necessarily need to know on a second-by-second basis, but at the end of a month, at the end of a quarter, it might be worth having a look and seeing if you can predict which clients are at risk of leaving, so you can focus a little bit more on them, whether it's by giving them a call. Having a little bit of headset issue there. Whether it's by giving them a call or just kind of checking in on them or refocusing some of your marketing or the products that you sell. Next, you have credit risk analysis. Batch scoring can be used to analyze credit risk by scoring credit applications in batches and flagging any applications that are deemed high risk. Again, not necessarily something that needs to be done in real time. There might not be a user who is expecting an immediate response. So it's a good case to kind of batch all of this data together and do it like that. Finally, you have forecasting. Batch scoring can be used to forecast future trends and events by scoring the historical data in batches and using machine learning algorithms to make the predictions. So now, my preferred tool is Azure Functions. An Azure Function is a serverless compute service provided by Microsoft that allows developers to create and run event-driven, scalable, and cost-effective applications without the need to manage infrastructure. So what does serverless mean? Serverless is that the cloud provider takes care of the underlying infrastructure, such as servers, networks, storage, all of that sort of stuff. Serverless is a little bit of a confusing word because it doesn't mean that there are no servers involved. Everything has to run on a server, but rather it means that developers do not need to manage or provision the servers themselves. The cloud providers will do all of that sort of stuff automatically, and they will manage the required resources, scaling them up and down as needed, and handling the incoming traffic. So one of the reasons that Azure Functions is great is because of that scalability. They are, as I've said, a serverless compute service, and it will automatically scale up and down to meet the demands of the incoming requests. That means that it can handle large volumes of requests, which makes it ideal for sort of machine learning use cases, because you might have ebbs and flows in the traffic. There might not be many people using it at night, but during the day, you're going to get a lot more of an influx. You don't want to constantly be running a huge cluster or a huge server to handle thousands of requests a second, when at night you might get 1 or 2 an hour. So by using something that scales, you can scale it up to handle the load, then it will scale back down, which leads me on to the second reason Azure Functions are excellent, which is that they're cost effective. They are billed on a pay-per-use basis, meaning that you only need to pay for the computing resources that you actually use. So if they scale out to handle the period of heavy load, then you will pay just for that, and then they'll scale themselves back down, and you won't have to be paying for these huge servers while they're not in use. Another reason that Azure Functions are great is that they are flexible. They can be written in several different programming languages, including C#, Java, Python, and JavaScript, and that gives developers the flexibility to choose the language that is best suited for their needs and to easily integrate with other Azure services. And finally, they're super easy to deploy and manage. You can fairly much do it in 1 or 2 clicks. You create a resource group, create a function app, you write a little bit of Python code, HTTP trigger, all of that stuff, push it up with 1 click of the button in Visual Studio Code, and you have a live endpoint that you can use to query your models. So now I will take you through a little bit of a basic implementation of what this might look like. So it is a HTTP request. So you have a user who has an endpoint. They will send their request, which will contain a little packet of information that they want to receive a query on. The function app will process that, and it will respond with the prediction from the model. Inside the function app itself, there are kind of 4 main stages. The first stage is to read the message. You need to make sure that there is actually some data that you do a prediction on. It's no good trying to do a prediction on an empty body if someone's just sent you nothing. You also need a model to actually do the predictions. So the next step will be to load the model, whether that is from local storage or whether it's added as part of the container. You can load the model to be used for predictions. Finally, you might need to do a little bit of pre-processing, changing the data around, computing some more fields, maybe doing some lookups before you can then query the model, get the result, which is returned to the user. Now I'm going to take you through a sort of very brief code example of how you might implement each of these steps in Python. Then I'll do a demo and show this thing working in real time. So the first step is the read message step. This is very simple. A lot of the kind of functionality is built into Azure functions. So the function will receive a HTTP request, and quite simply, you can get the message from the request. You can log it so that you have visibility of what the function app has been doing. And then if there's any sort of error, or if it's empty, you can return error to the user, so you don't need to move on to the next stages. Waste a load of time trying to load a model when you don't even have a message or any data to query on. The next step is loading the model, which can be done very simply, opening the file and loading it using Pickle. Pickle is a fantastic way to package up models, particularly things like sklearn models, as most of that stuff is handled by all of those libraries, and there's very little that you need to do other than run a couple of lines in Python. And again, if there's any problems loading the model, you'll want to return an error to the user so that it doesn't try and pre-process some data when there's actually no model to use it on. Next is the pre-processing step. A lot of the time, these HTTP endpoints will receive data in JSON or XML formats, which is great for sending super lightweight messages, but often it's quite hard to plug a JSON dictionary straight into a model and get a result. So you'll need to do a little bit of tweaking of the data, maybe restructuring it and reformatting it. In this example, you get the values from the JSON message and you reshape it into a list of lists, which is the perfect input format for the model that's been trained. Again, if there's any issues there, you can return an error because it saves running bad data into the model. A lot of these things you'll see are returning errors at the end of each step just to save time and give a faster response. Before finally you query the model, which is as simple as calling the sklearn predict function, getting your results. You can then package that result up into a little JSON output. You can put the prediction values, then you can give a little bit of information about what model was used, about the input data and what that looks like, and return that to the user. So all of that stuff sounds great on paper, but now I'm going to try and do a live demo just to show this working. So bear with me a second. I will just need to swap my screens over. So I might need our kind host just to re-add my screen, as there's a lot of swapping about. There we go. We're looking at me, looking at myself. So where are we? There we go. So we're in the Visual Studio project, and in order to have a look at HTTP endpoints, I like to use Postman. You can also use things like the curl commands, or you can use the Python requests library, but Postman is a quite easy way to build collections of requests and then quickly see the responses. So very briefly to go over it, I have a very basic function here, which will load the very common iris data set. Pardon me, from sklearn, and it will format it, it will give it some headers, and it will give it some classes. There's a function to split the training data into train and test, and then finally a very short script to train a number of machine learning models. Just very basically, no sort of hyperparameter optimization because it's an easy data set. It'll train the models, and then it will save them all out into a repository of pickle files, which are stored locally here. So you can see I've got the 5 models stored there before we move on into the function app. So we have the function app. Because it's all done in Python, it can all be done in a single script, which makes it super easy to work on and super easy to deploy. So you have all of your imports at the top, which are just the very basic things you need. You've got Azure functions, you've got NumPy, and you've got a couple of libraries for data formatting and logging. So the first thing that I did is I create a function to handle error messages. It gets quite clunky in the main body of the code every time you need to return an error, having to do a sort of 4-line return statement. So I just packaged it up into a single function where you can pass in your error message and it will create a response for you, just saving a little bit of space and keeping things tidy. Now we get into the main body of the code. So this will be the same across every single Azure function. It has a main. It requires a HTTP request from the Azure function library, and it provides a HTTP response. a lot of that means that there is a library there to do all of these things for you. So the first step, as I mentioned, is to read the message body, load the model, which will come from the model files that we've got stored here when the app is deployed or when it's run locally, do the data pre-processing, and then query the model, return the output. So we want to have a look at that thing running. So if you've already got your Azure functions built, you simply need to go into the terminal and type func start. That will run everything for you locally. It will give you the local addresses for the local host, and you can simply create your requests. So we'll take a look at a range of requests here. I've got 4, which I'm going to go through very quickly. First of all, you've got the basic request, which is just calling the endpoint, but it provides no body. It's going to have a problem. So you send the request, and then you can see it returns as 500 error because there's been no JSON message received. And then in the logs, you can see exactly the same thing there. You can see that it has detected the error and it has returned something intentionally. It's important to have that error handling built in, because if you just let it run and there's a Python error, it won't return a particularly meaningful response. You will just get a 500 internal error, and there will be a load of gibberish, which someone who's not a technical user would understand, but this allows them to kind of easily figure out what they've done wrong. Next, we're going to send a message which this time has a body, which is quite simply a JSON packet. But rather than having information that the model is looking for, we've got the height and the width, which are some strings and ridiculous values for the size of an orchid. So again, we send the request and we get the failed to query model response, which isn't quite as meaningful. It doesn't quite give you the information, but it's a little bit harder to know in this scenario what's wrong. But at least we know that there is a problem in there somewhere, and we don't just get a random error message. Finally, you have the example where you provide a proper message with the correct values and the correct data types. You've got the length and the width of the sepals and the petals. Not that I quite know what a sepal is, but either way, this is what's required to get the results from the model. So you can hit send. You can see here that this is expecting to be a 0 because we're using this on some data we've got labeled already. You send the response. You can see everything that the function app is doing from the logs, and you get a nice response here. You have the prediction, you have the model that was used, you have the inputs that were provided, all packaged up in a simple response. And it's as easy as that to create a function and query a model. You can then host this in Azure, and you can create a proper endpoint. And so you could have it live on the web, so that anyone who wants to know which category of plant they have can query your endpoint and get results in real time. It's fast, it's an easy implementation, but there were a couple of problems and a couple of things that could be improved. So I'm now going to jump back to my slides and talk about a slightly more advanced implementation to tackle a couple of those issues and to build a slightly more robust solution. So give me just another second to get all my slides back up. I should really have a third monitor. Would make this easier. All right. There we go. So my slides are back up. If they could just be added back onto the stream, fantastic. So we've done the demo of the basic implementation, and now we're going to look at a slightly more advanced version of it. We're going to bring in a couple more tools, and we're also going to increase the complexity of the flow within the function app itself. Still remains a HTTP request, so the user will send a request and receive a response. It's just the inner workings that we're changing around a little bit. And a couple of libraries that we're going to use are Pydantic, and we're also going to use MLflow. So you can see that there's a few changes here. The first is that the model is now a global variable outside of the flow. So every time you run the function, you don't need to keep loading the model. You can have it stored, and for that instance of the function, the model will always be there. However, that has problems. If you update your model, you'd have to restart all of your function apps in order to get the latest version of the model to be loaded, which isn't necessarily what you want, because that would provide downtime. And if you've got a very high load request or very high load volume, it will back up very quickly and it might be hard to catch up. So you can use the root parameters of the Azure function to dynamically reload the model with a single request to save you having to turn everything off and on. You then read the message as with the basic implementation. Next, you have a data validation step, which is to check that the data that you have received is actually an appropriate input for the model, and also to provide a lot more responsive and clear feedback on if there's any problems. You then have a step to check that there is actually a model loaded, because with loading the model outside of the flow, you might not have loaded a model, and then it'd be very difficult to do any sorts of queries on a model that isn't there. You can then pre-process the data as before, query the model as before, and send your response. So first of all, just a little bit of an introduction for anyone who isn't familiar with MLflow. It's an open source platform for managing the end-to-end machine learning lifecycle. It provides tools and APIs that allow data scientists and machine learning engineers to track experiments, package and share code, and deploy models easily into production. It's language agnostic and can be used with pretty much any machine learning framework, including things like TensorFlow, PyTorch, and scikit-learn. There are two key things of it which are great in model deployment, which are models and model registries. MLflow models are something that allow users to package machine learning models into a standard format that can be easily deployed to a variety of platforms, including cloud services, mobile and edge devices, and particularly Azure functions. You then have the model registry, which is a centralized repository for machine learning models. It provides a good amount of version control, access control, and a number of collaboration features, which allows the team to manage and share their different projects and models across everyone. Next, we have the kind of model code itself. This is all quite simple. The first step is to make a connection to the MLflow client. So I personally use the managed MLflow in Databricks. So it's as simple as adding a couple of environment variables and doing the Databricks config in the background on your local machine or on your hosted environment. You then simply pass in the Databricks URI, and the amazing MLflow library will do the rest. You create a client, you set the tracking URI, and you're good to go. Then you create a global variable for your model outside of the main. I always default it to none, so that I can make sure that I'm loading the correct model at the correct time if it is a fresh start for the instance of the app. And then quite simply, you have a function called load model, which does exactly what it says on the tin. It loads the model. And that's as easy as calling the MLflow load model function. All of that's handled by them. They will do all of that for you. And then you can simply send an output message that you've loaded the model and you're good to go. Next, we have a little bit of look at the root parameters. So one of the things I really like to do is add a particular flag to the request, which is specifically for reloading the model. So at the start of the main, I will check the root parameters. And if there is that reload flag there, I will simply call the model load function that we've just shown. If it fails, return an error. And if it succeeds, just return a response letting the user know that the model has been reloaded, which means if you need to do any of this stuff, change your model, you've just had a great idea, you've trained a new model and you want to change it, you can simply call that request, keeping the app live with minimal downtime. Next, we'll move on to data validation. So there's a fantastic library I love to use called Pydantic, which is effectively a data modeling library. It's got a huge amount of functionality in it to build kind of data classes and data types, and also to do validation and things like that. So the first step is to build a data model for your model inputs, which can be done quite simply by importing Pydantic and then creating a class which inherits the base model. And then you're able to define your 4 features and the data types that are expected for them, which means anytime you're trying to make a query and it does this validation, it's looking, is there the sepal length, the sepal width, the petal length, and the petal width, and are they all floats? Next, you can add a very small section in the flow of the app itself, where it will effectively create that data model. And if there are any errors as part of that, you'll be able to return exactly what those errors are, so the user can see their problems, and it will give them advice on what exactly is wrong, if there are missing variables, if there are incorrect data types, things like that. And then finally, you have the check model step. This is just a safeguard to make sure that the model has been loaded, because we declare it as none. If when someone has made a request, that model variable is still none, it will simply call the load model function to make sure that they are using the most up-to-date model in the request. So now I'll go into a little bit more of an in-depth demo of how that works. So you'll have to bear with me again as I mess about with all of my screens. Put that over there. Got these here. Haha. Get the knack of these things now. So I am going to share this one. So if you can add that one back in. Perfect. So we can get rid of the train model function and the initialize function. Yeah, I've got a little bit of time, so I will take a look firstly at registering the models to MLflow and how that works. So there's a very basic script here. It ignores a lot of the great functionality of MLflow, but it's just a very fast way to get those models registered. So the first thing that you need to do is you need to set the tracking URI to be Databricks. It will use the environment variables in the background. And all this script will simply do is it will get a list of all of the models that I have in my function app, which are the 5 here. It will get the name of my experiment in MLflow from an environment variable. It will set the experiment name, and then it will start a run. What that will do in this instance is it will open each model file, and then it will just log the model to MLflow, and that's it. MLflow has a lot of functionality to store things like hyperparameters, to store things like the accuracy and the results of the model, but just for simplicity, I'm getting it just to log the model and go from there. So all we need to do is, back in the terminal, run that script. You can see that this thing will think for a minute, and then it should run. Yeah, there we go. So you can see that it is registering the models to MLflow. Some of them already exist, so it is re-registering a new version. So we can now jump into MLflow here, which I use the Databricks managed version. You can see that you have got your models in this tab here, and you can see all of the models that we have. We can see some of them are on version 6, which have been updated just now, and a few of them are from yesterday evening at version 5 when I was doing a demo run. And when you refresh MLflow, you can see that those models are updating, and we can find the latest versions of the models there. We will just wait for that last one to finish. So now you can see we've got our random forest model, which is the one that we want to use for the classification of the plants. And we might want to use the most up-to-date version. So all we would need to do is simply go into the model, look at the version 6. Oops. Then change the stage. And we want to go from none to production. Change our production model. And as simple as that, you've now changed the model that's in production. You can see the production model is now version 6. And this will become useful a little bit later when we get further on in the demo and look at live reloading of the models. So we've got our code to register the models to MLflow. We've had a look in MLflow and we've checked that the models are definitely registered. So now we can ignore the models that are stored locally, as this next implementation will just look at MLflow. So again, it is very similar to the stuff that we looked at in the slides. It's in fact exactly the same code. You can see it's got the load model functions, it's got the errors, it's got the pydantic class, and then it's got the main, which will go through all of the steps. So I will start up the function app again, and we will take a little bit of a look at the various features that we have. So we have got the advanced reload, which is the reload parameter I was speaking about. So previously, when you were to run the function, you would just run the API/basic, and that would run. But now we've got this root parameter in to specifically call a model reload, which we will run and have a look at in just a second. We've got things like the validation errors. So we run the code here. We're sending a packet which we know is wrong. It's got the sepal length and the sepal width. It doesn't have the petal length at all. And also the petal width is not a double, it's a string. So if we're to run that one there, we can see that it will trigger some errors within the function app. And rather than just returning a generic error, it will tell us specifically what's wrong. So it will say there is a request validation error, and there are 2 validation errors in the iris input. The first one is the field length or the petal length, and it says that it is a field that's required, which we know isn't there. And secondly, it's got the petal width, and it will tell us that the value is not a valid float, which means all we would need to do to fix this is to make that a valid float and to add in the petal length. So we can have a look at what one of those requests will look like. We can see here that we have the data from the previous requests, which we're going to send to the advanced function this time. So we hit send, that thing will begin to send. You can see now that the input validation was successful. It begins to load the model. It loaded the model successfully, and then it queries the inputs. So this took overall about 1.5 seconds, which is quite a long time. But then this brings us back to the fact that we're storing the model as a global variable instead. So first time around, when it gets to this section of the code, there was no model because the function app had never reached that point before. But this is run now. It's updated the model. So if we were to call the request again, you can see that it's much faster. It only takes 30 milliseconds because it can skip that model loading step. It can go, right, we've already got the model. Let's go straight into the querying, and we get your responses. So you can send it with a different response request. So it's this time going to send values which should return a 1. You make the request, and again, lightning fast, it can give you a response. It doesn't have to reload the model. That is effectively how this thing works using MLflow. If we want to change the model and get a little bit more out of the reload function, we can go back into MLflow here. We go, actually, I don't like version 6 of the model. So I can go into my model. I can go back to version 4, which I was using previously, and go, you know what? This version has been archived, but I want to put it back into production. So I can move the model into production simply by staging it, maybe giving a comment if you're working with people and you want to be good, but I'm going to ignore that just for the speed of the demo. So now we can go back to the models, and we can see that the version of the random forest model that's in production is back to version 4. So now we need the function app to reflect this. It's now using a different model. If we were to run this function again here and just make the request, there's a model that's already been loaded. You get the fast response, but it's not using the most up-to-date model. You can go back to this reload request, and when you look in the code at what this does, you will see it will check the root parameters, it will find the reload, and it will call the reload model function for you. So you simply hit send. That will reload the model. So we can see that it took a little while, but the model's been reloaded. We can see in here that it's been reloaded there from the logs of the function. And when we send the request lightning fast, the model's loaded, but it's now using version 4 of the model from MLflow rather than the version 6 that it was previously. As we have, I think, a little bit of time, 5 or 6 minutes, I'm just going to talk through deployment. There is a deployment slide which just says deployment, and I'd go straight back into the demo. So we don't need to pull that one up. Deploying function apps, especially if you're using Visual Studio Code, is very easy. All you need to do is you would need to go to Azure. You would need to go to your resource group. You would need to create a function app, which is the app itself which manages all of your functions. That's very easy to do. You can create them. You can search for, if I could type, search for functions, and there's a create, which just takes you through a little wizard to set it up. It'll ask you to do things like select your license, select your resource group. You can choose things like the Python version, anything like that. You can set up a little bit of security, whether you want monitoring, things like that. But you go into your function app once it's created. You can see that it has a couple of functions in it already. But how do you get them there? It is pretty much just one button click from Visual Studio Code. You can go, if you've got the Azure Functions extension installed, you can go into it. You can see the workspace here. We can see the 2 functions, and there's a button there which is called deploy. Just stop the local one from running. And very simply, you click the deploy function app. It asks you which function app you want to deploy it to. I want to deploy it to my real-time scoring function app. I select that. It's kind. It tells me that there's already a function app there. Do I want to overwrite it? I'm happy to do that. So I hit deploy, yes, hit deploy, and you can see now that the function app is deploying. You can have a look at the output window, and that is going to do everything for us. It's going to package it all up. It's going to have our requirements. All of that stuff is going to create the whole environment as we've laid out in the project, and it is going to deploy it to that function app slot. It takes a little bit of time. Font size increased, yes. Sorry about that. It's probably a bit late to increase the font size now, but I have a Git repo with all of this code in, so I will be able to share that at the end, and then you can have a look at the sort of templates and the worked example and all of the stuff there. So this thing is still just running, doing its own thing, but it will eventually deploy. It's a slightly long process, but it's only one button click, so it's not too bad. We don't necessarily need to sit and watch it run, but you get the gist. You can press one button, you can deploy. There's a couple of secret button clicks in the background, which are creating your resource group in your function app, but that is everything that there is to it. So does anyone have any questions? Got a few minutes, I think.
Thank you, Alex. That was really good. Yeah, I enjoyed that. So we do have a few questions. So we have one from Shmuel, and he is asking how scoring and Azure functions in AI can support effective management, social and other state and municipal services.
I think I might need a little bit more detail on that question. So one way that the functions, Azure functions in AI are useful and a great way to have an endpoint is for something, for example, like in the insurance industry. If you have a fraud model, you might have a process which receives the data from the user. It does some lookups and things like that, and you want to make a prediction as to whether it's a fraudulent insurance claim. So you can have your model hosted on Azure as an Azure function, and then you can simply pass in all of the user data, make that request, and easily add it into part of a pipeline that already exists. Any library which can make HTTP requests and handle JSON can easily make requests to function app endpoints. You can also write them to be a little bit more specific. They can handle things like XML quite easily. So if most of your platform is built using something that favors XML rather than Python and JSON, you can have your function app handle an XML input. You can parse it using a number of Python libraries. My favorite Python library for handling XML is called Beautiful Soup, which has a great name and is super easy to use. Which doesn't quite answer the question, but hopefully goes a little bit of the way to doing it.
Oh, thank you, Alex. We also have another question from Gavi. So she asks if there are any tools you would recommend that can be used for data validation within Azure.
So there are a number of tools that exist that do similar things, but I personally like to use Pydantic because it works in a very similar way to if you're creating a fast API. Fast API might even use Pydantic under the hood. I'm not quite sure. But if you wanted to look at a different way for deployment and you wanted to create a fast API and deploy it in something like Kubernetes, that has its own sort of data validation and data modeling built into it, which might be another way of doing that while still using Azure.
Nice one. Thank you. I've also got a quick question, actually. So with Azure functions, obviously, say you have the API facing a web app or something, how bad is the cold start issue? So at the very start of the day, the servers haven't been warmed up correctly. Is it bad? Is there a way to deal with it?
Yeah, so that's a great question. The sort of cold start time in Azure functions isn't too bad, which is not a particularly scientific method or scientific metric. But there are a few things that you can do within Azure Function to sort of handle that. So in some of the function app configs, you have a lot of settings about the scalability. One of them is you can effectively have some warm instances, which you can set off effectively just by some of the drag and drops and the sliders in the Azure portal, which allow you to have ready to go compute instances, which have a much quicker time to boot up. But because they're not in use all the time, they're just warm. They have a much lower cost associated with them. So if you know you're going to have a period where in the day you might be expecting 1,000 requests a second for sort of 9 to 5 working time, and then everything will calm down at night, you might want to have 20 instances which are always warm. So that means at the start of the day, when those requests come in, they can immediately get running. you'll be able to handle that load, and then at night they will scale down. They won't scale down to 0, they'll still stay warm, but that means when the morning comes around again, they can scale up a lot more quickly. And as well, some of the tools that you get through the portal and for managing scalability is you can do things like set caps on stuff. So if there is a certain amount of instances you want to run, you can set a maximum scale out limit. So you might only want it to ever scale out to 20 for cost saving. So, you can leave it at the absolute maximum and it will scale out indefinitely. But if you're working to a budget, then you can set limits on things like that to not only allow it to scale out and handle loads, but also to sort of cap any costs that you might incur. Also, in case of someone finding your endpoint being a little bit malicious, it's not going to scale out indefinitely and break the bank, making thousands of requests a second and scaling out to thousands of instances.
Nice one. Thank you, Alex. Yeah. Do we have any more questions? I think that's it. So yeah, just want to thank you for coming along, and yeah, really enjoyed that talk. So yeah, feel free to stay around and watch the other ones. But yeah, thank you for your time.
Thank you for having me.
Cheers. All right, so we have a little bit of a break. But we'll be back at 11. Also in the Johnny 5 room at 11, there is an introduction to TensorFlow. We will be joined later on by Khushiyant, who's going to talk all about the role of DevOps and deployment and maintenance of ML models. So yes, we'll take a short break and we shall see you in a little bit. Hello, everyone. I hope you had a good break. Right, now we are back for another talk, and I would like to introduce you to Khushiyant. How you doing?
Hello.
Hi. So, Khushiyant is going to be talking to us today. He is a research assistant, NTNU and DAAD scholar at Ulm University, and he is going to be talking about the role of DevOps in deployment and maintenance of ML models. So, yeah, over to you.
So, first of all, hello everyone who is ever present here. So, the main thing that I'm talking about in this session is obviously the role of DevOps in deployment and maintenance of the ML models. So, without any further delay, let's start this thing. Uh, so, who am I? First of all, as Luke said, I am research assistant at Norwegian University of Science and Technology and works in the neural imaging lab. Also, I'm a data scholar and will joining Ulm University in Germany in the very upcoming weeks. So now let's move to the session for. So let's discuss our agenda first. We have first we will go through how the AI/ML model life cycle is done. So how the data is prepared, how the model is validated, how it's finally deployed to the public. Next, we'll be just discussing some what is DevOps. This session is introduction to DevOps. Is basically for our non-tech watch participants or the persons who are not very familiar with DevOps. Next, we'll just touch the topic about version control and CI/CD, and then monitoring demo. I'll be having a very small demo using container technologies and TensorFlow serving to show you how ML model is deployed. I'll show that on a very local system, but you can try that on the server as well. Then I'll discuss about retraining and how the data security is implemented for the ML models. And then we'll discuss some best practices that you can follow. Okay, so let's start. First of all, now we have our AI model life cycle. So it contains many steps. It is like hundred of steps that you can see in there. But if you broadly classify that, it starts with the data collection, explore how to analyze the data, how the model training is done, how we monitor, deploy, and all that stuff. But in this session, we'll likely to stick to the model deployment, monitoring, and some basic analysis of how the model is working. So, but for our viewers, let me explain a very brief about how data is collected and how it's analyzed. So there is a very good saying: you should know your data better than your model. So when you have data collected for your deployment or development, what you do first of all, you should clean the data. The data present all over the internet, it's not so much structured. You do not get the very Kaggle stuff that you usually get from a website called Kaggle. So after collecting the data, you have to perform many steps throughout. Like you have to normalize the data, you have regularization of the data. After that, you should analyze your data, how the data is basically correlated to various streams and labels. Then we have data annotations and all that stuff. But let's skipping that part. Next, we move to the model training. Basically, you have to know your data to get your model selected. This part of model selection is a very crucial part if we see, because every type of data requires a certain amount of parameters, certain amount of certain type of model that should be chosen. Now we are diving very to the model deployment, monitoring, and retraining thing. So now we'll be moving to the major stuff. after we have just gone through what's data collection and data annotation. So let's move. Okay. First of all, starting with the what is DevOps actually. So if I explain this term in the very layman language, it's you are automating your build, test, and release process. These build, test, and release phases are very elaborative and can contain hundred of steps if you were to elaborate. So, why we are using DevOps? You might think that it was not so popular in earlier times when we do not have like millions of calls per second now. There are some companies who are getting millions of calls or requests per second. We have to handle that, but this was not the scenario like 7 to 8 years back. So that was not so popular at that time. But we are now required to have a very scalable design in for our infrastructure of models, ML models, because as you have seen in today's time, it is getting so much popular, and so we have to know what's DevOps as a developer. I'll say that it also affects the life of a consumer as well, because MLOps. Okay, MLOps. First of all, let me explain the term MLOps before going further. DevOps you can see as a universal set of some best practices operations for deployment, and MLOps is like a subset to it, having very specific requirements for ML operations or ML deployment. Okay, so how MLOps or DevOps is helping us? So there is a something called time to market ratio, which means how much time is required for a product or a ML model or a service or a software to reach the public or when we start its development. So as you can say, if I started the work today, and if the model or the product will be going to release in like 2 weeks or 2 months, that would be a very good thing for the company as well as consumer, because you don't have to wait for a very long period of time, which was not the case, which might not be the case if we have to completely do that manually, because that's why we are learning DevOps, that we are automating that process of like testing and stuff, which will go through in better in few minutes. Okay, so basically what DevOps is doing, it is we are automating the stuff of like building, testing, and release process, and it's helping us to make our work easy. That's the stuff. Okay, so what's let's see what are the processes. Again, this is the same thing. What are the processes involved while developing or deploying a machine learning model? So other than the data collection and cleaning of the data and analysis of the data, we have something called like designing of pipelines, designing of infrastructure, how the data will flow throughout, how the data will be tested, validated, cross-validated throughout the system. Okay, so this is all about that. We have just discussed this thing previously in the AI ML AI model lifecycle. This is the very same thing, just some additional steps like testing and debugging. Your data, I'll say your ML model's data, even the code base should be regressively tested and debugged. So this is one stuff. There is something called serving infrastructure. Actually, I'll show in a very bit like how to serve a model. So serving a model plays an important role in many things. Like it will help you in monitor and log your stuff. Other than that, it will ensure that your system is not failing just because you have much number of requests as comparison to your testing infrastructure or testing environment. Okay, so let's see what is version control. Many of you must be familiar as developer with some version control systems like Git. Okay, so version control systems like Git and like CI/CD pipelines that we usually develop for automating that stuff goes hand in hand. So let me explain you what is continuous integration and continuous development in terms of like version control. So you can differentiate these two things on the level of development and deployment. So continuous integration, as I say, CI, works on the level of developer, where he designs something for like building pipelines. So there are some tools that I prefer, like there's Jenkins and Travis CI/CD. So I'll say these tools are really nice because as Jenkins, I personally use that. Has a I'll say, yeah, it has many features that are not present in softwares like GitHub workflows or GitHub CI/CD pipelines. So using the softwares like Jenkins and Travis, it helps our developer to build a pipeline so that he could automate some stuff which is kind of repetitive, or I'll say there's a task which can be automated and might not need some decision making skills as comparison to a developer. So here I'm saying that you can have a testing environment or a testing framework which might not require the input of a developer, but without CIC, continuous integration, he has to give that input, and it's like the waste of resources and time for a developer as well as the company. So to avoid that, we use continuous integration on the developer side, where what he do is he builds a pipeline which automates like testing process. There are like thousands or millions of tests for unit test or system test, which he might not to manually check and log and monitor. So this is all handled by continuous integration. If we move further from the step of development, we move to the process of deployment, and that's handled by continuous CD, basically CD deployment. So where what is done here basically is you have your code ready, you have everything ready on your development system, and you want that to be publicly available. It means you are dev, developing or making your code base or making your testing product available to public, so they can test or have you can have the reports. But again and again releasing that software or deploying a software or even an ML model requires some kind of input, which is again a very tedious task and might not be uh, a rewarding task as comparison to some developer can do. So we use release pipeline there. Or what is a release pipeline? There is something called GitHub workflows. I'll show you in a bit. There is also we can like uh, we can test the system on A/B testing. We have something called A/B testing. That is also something I'll show you in a bit. Uh, Basically, we are writing a pipeline so that we could get the reports from the final journal public. We can deploy the system again and again, ML model again and again, by using a retraining pipeline. That also comes under like CD. Okay. Here is a very basic example of a Jenkins pipeline. How you basically write a Jenkins pipeline. You define that by pipeline, then you define any agent, how the stages are involved. Basically, Jenkins pipeline works in stages. So you define different stages. Like in this example, we have checkout stage, build stage, test stage, deploy stage. Okay, and after these stages you perform some operations. So these things are dependent or basically are maintained on container technologies. Container technologies are basically it's basically, as you have seen, many our users might have used like VMware where you are using a different operating system within yours, and that is working perfectly fine and completely isolated from your host system. So try to imagine the very same thing without any bloated softwares or bloated anything, and it's giving the bare bone functionality of that operating system to you. So that's a container technology in the layman terms. And we have some examples like Docker that I'll be using in the demo right now. And we have Kubernetes. These are some two popular ones that are currently used in the production or even the testing phases. Okay. Before moving to our demo, let's see how basically a ML model is monitored and logged. Basically, there are some matrices or parameters that a ML model is tested on. First one is stability. So a ML model, there is a saying called ML models are never finished, because they have to be updated with time, with the data that is generated in real time. So there are two things. There's a prior probability shift, which should be like keep in mind, and there is a covariant shift which should be kept in mind. For prior probability shift, basically it's a distribution shift for a predicted value and on the dependent variables. So what I'm saying is, there's a data which is that is predicted, and you have to relate that with a dependent variable. uh, and there are some tools, or there's some things like PSI, the concept shift, error statistics. These are some things that should be kept in mind while judging your ML model on stability. There is also something like covariant. It's the very same thing, but it's the correlation distribution shift in independent variables. Previously, it was on dependent variables. Okay. Next thing, I feel that performance metrics is up more important according to me, as I've seen that sometimes the data you have created a very good model, it has like 90% plus accuracy, and you are really happy with that. But the conditions like you might have not ever imagined might come, like COVID-19. uh, the things that were not accounted for, and you might have not imagined that something could have ever happened like that. And same thing for the model. Our model could have also not imagined like COVID could have come. So our model start predicting very deviated data values in comparison to pre-COVID conditions. So I'll say that there was a model which was predicting the revenue for a company pre-COVID phase. But as the COVID came, and we are in like post-COVID phase, so that model, if that might have been like 90% plus accuracy model, but now that would not perform nearly as that much, because there are some factors that are now involved in the performance. Like there is a impact of COVID on different financial structures. There is an impact of COVID on various companies revenue structure, even the layoffs. These are not accounted due to COVID in the previous model. So what needs to be done? You have to retrain that model. Basically retraining a model that comes in the further slide, but giving example, uh, like the pre-COVID data was not there in the model. It doesn't know about that COVID has come. So you have to tell it that COVID has come and it has impacted our company, the environment as such. So you have to tell that, and that's basically retraining. You are retraining that from that model and teaching it what has changed now. There is also different metrics. Basically a more technical one, it's operational metrics, and what it accounts for, like how the basically ML model has to scale, how the request should be handled. So a more number of requests do not lag the system, or basically how a system will perform in the for the journal public. So this is operational metrics, but I have not included that because these are the ones that you might be able to understand better. Okay, let's see a demo I prepared. It basically uses Docker and TensorFlow serving to deploy a toy model, and I'll show you how it provides support for gRPC and REST. Okay, just a second. Just a second, everyone. Okay, so I'll be using I'm using M1 Silicon, so it might be different according to your systems, because currently TensorFlow serving do not support it directly on the native versions. So I'm using a community build. So let's see. Let's make simply a folder, TF serving, and okay. Here's the image you have to pull if you are on a silicon-based Mac, Emacs KI. It's a community build that I am using for TensorFlow serving. If you are not on the silicon Mac, you can use the official TensorFlow serving image that supports, I think, every other than this silicon Mac M1. So you are free to use that. The process will remain the absolutely same. There's no difference in anything regarding other than this. Okay. So first of all, let's next one important thing. I'm using a toy model, which has a working like y equals to half x plus 2. Basically, what it does, it multiplies the value with half and adds 2. So this is the toy model, not a final working model. But if you have your pickle file, you can use the same thing on the terminal and just change the model path, and it will work the very same. Okay. Next, let me show you. Okay. So this is the command. It's docker run. Docker run, what basically it does, it runs any image that you specify. Okay. There is like a minus p flag. It exposes the port from host machine to the container. Okay. There is a mount flag. Mount flag, what it does, it binds your volume. It's basically your storage location to it binds or basically links the storage location from your host to your container. And there now, after this is the most important one. If you are using if you are using TensorFlow serving to serve your models, one more thing that I would like to include in this, there are some features that TensorFlow serving provides. Mainly 3R. It provides us out of the box support for gRPC. It's an open source procedure call framework, and it's like more 7 to 10 times faster in get and post request. And it also provides the out of the box support for REST API. It also provides a support for batch inferencing. After running this command, I'll explain you what's batch inferencing and how it helps you to scale your infrastructure, or how it helps you basically. Okay. Explaining this command, it's provided by TensorFlow serving. So your source, it's the source to your model. It's the source to basically your code, and it's there is a target based sources where your test data or the data is present for the model. There is a target, you can specify anything where you want to save it, generate some configuration files. There is some environment file. There is an environment variable that you specify here using -e flag, environment flag, and the variable name is model name, and you specify the model name. It can be anything. You can change this. There's nothing specific to this, but you can change this, and then you specify the image name. Okay, let's run this, and then I explain you about what's batch inferencing, because it is providing it out of the box, and I'll show you what it does. Okay, so here you can see we have a container running, and what it is doing, that it's serving your toy model. It can even serve any model. It doesn't matter. It's a classification model, it's a regression model. If it is even a CNN based model, it doesn't matter. You have to just change the source of your test data or your data, and there are minor modifications like model name. You can keep it anything, and so you just have to change the source to your test data, and it will work fine even for the CNN models. Okay, and it works really well with TF models also. Okay, next thing, let's test this. Okay, I have the another tab. I'm using curl. I'll show you. I can show you even using the VS Code, but let me show you using curl command. Okay, so I'm using curl command here. So I just use curl. I pass. I basically pass the JSON body to our REST. I'm using the REST point, REST API point. That is running on port 8501, and let's see how it predicts the data. Basically, what it will do is it will multiply the one every value and adds 2. Like half of 1 plus 2, it's like 2. It should come around 2.5, and see here. So it is coming like 2.5, 3.0, and 4.5. So as we can see, it's working fine. We have served our model on our local system. So what it is telling us, just let me stop the container. That command will stop the container. Okay, I'll explain. I was explaining about batch inferencing. So think of, like, you must have heard about ChatGPT in the while now, and you have seen it prompts you with a message that they are scaling their infrastructure, their structure, or they're scaling their product. So what it is, what does this mean? It was initially a research preview. What it means that it was like here, if I release this product, this toy model, to public, or by writing my own Flask server or Flask image, and I'll give that to you. And example that many thousand, 2,000, or even 100,000 people are using that. I thought that that system will work everywhere fine, but that's not the case every time. How? When the number of calls increase, there's a thing called lags in the request processing. So sometimes the system might not scale properly. It might not give the results as you were thinking it might give on your local system as it was giving, because you are giving like very simple 1, 2, or 10 calls. But now that's not the case. So TF, or TensorFlow serving, provides out of the box batch inferencing. What it does, it first of all takes a batch of request calls, like it might be a batch of 1,000 calls. So until and unless it do not get like batch of 1,000 calls under a specified period of time, it will not invoke the model. So it will be not invoking the model for every call. it will invoke the model for a single batch instead of a single call. So that will perform really well, because we do not have to create different instances of the model for every call. We are creating the instances of the model for every batch. Batch you can define, batch can be like 100 batch, size of 100, size of 1000, and you define a certain period of time. Within that period, you have to see if the batch is completed, you invoke the model. If even if it's not completed, you invoke the model. So that's how this provides a better scalability in comparison to your own written Flask server or your server. Okay, so moving back to our slides. Okay. Okay. Now, this is something we use in our academia. We use in our research purposes, like A/B testing and rollbacks. So A/B testing, give you the very basic example or a very easy example. Like there are two ice creams you have, and you want that you should know which one is better according to public. So you have 100 peoples, you distribute those two types of ice creams in like a batches of 50 and 50, and ask them about how's it. And that's the same thing we are doing in the A/B testing. So A/B testing is the way to compare two things and see which one is better according to a public candidate. It can be batch, it could be singular, it could be to the general public. And so it can be used to know which is the better setting, or which is the better parameters for your model. Example, we can take the example of a simple regression model. You might know that a learning rate, according to you, might think that learning rate of zero point 0.1 or zero point 0.01 is good, according to your use case. But you need to know if there exists any better way that you can do something. So you create two models, model A and model B, and you distribute those models to your public. And they will provide you the feedback if that model is really better or not. So here is a graph. Basically defines the p-value or probability value of errors. Like this overlapping of those thing defines that it's basically defines the conversion rate of the candidates, or it can be a group. What's the conversion rate? I'll say when you provide something to the public, and they might like or they might not like that, but there might be two groups who are liking the both things. So this is the conversion rate overlap, which defines the p value of the A/B testing. So here what it is doing, that there might be something which is liked by both groups, so you can't say which is better, which is really better. So that's kind of an error for you. Okay. Next thing is how we use it is in research purposes. We have to extensively research because we have to create something new. I was recently working on brain signals, and I had to see which one performs better, like a BERT network, a transformer BERT network, or a GPT-2 network. It's also a transformer based network. So which performs better according to some my use case. So I created two different models and distribute to some alpha or beta testing groups, and they provided me the feedback which is better. And so I fine tuned my model. So basically it's for fine tuning our model or model selection in a better way according to the feedback given. So this is how A/B testing works. So that's how we distribute two things and we ask for the feedback. And rollback, what it is, what's rollback? If the newer version of your model is not working as you intended, say you might have intended that it will work, you have got a good feedback, but it's not working as you thought. So we can roll back. Rollback technique, is present in databases. Even a version control provides you the feature of rollback. Rollbacks means you are downgrading the system because the new version is not as capable that was intended. So this is a rollback, and it goes really well with A/B testing. Okay. So now we have moved to the the last parts of the session. We have the retraining. Now we are left with retraining, data security, and best practices that you can employ into final DevOps practices. Okay. So what's retraining? As is mentioned in the earlier slides, uh, our model is never finished. Our machine learning model is never finished because the data grows and it changes with time. So your performance of your model is not static. Actually, it drops with time because it's not relevant as it was even a one day before. So you might have to create a new model because data has changed. The life scenarios, the environment has changed. So for that we require a retraining pipelines or retraining of the models. So here in the graph, as you can see, the if a model is static and you are not training it with time, it will definitely, the model quality or the model performance will really go down exponentially. As I have seen, it will go down exponentially. So to maintain that constant performance, or at least a comparable performance to the initial phases, you have to retrain the model. How a model is retrained? Basically, you collect the data, you collect a certain amount of data according to the current scenario, and you transfer learn the model's learning onto that. Basically, you are using that data to transfer learn. You are using its previous understanding of data and adding something new to its understanding. So like there is someone who's 10 years old, he might have a knowledge of like 10 years old, and if it teaches something, it he will use its previous knowledge to understand that thing. So here it's same goes with the model retraining. Okay. So now we have data security. I'll say in today's time and even in upcoming period of time, data security will grow. A need for data security will grow exponentially, as I'm saying, because uh, in today's world, that our society is dependent more on the data. So we will require the data security, and there are some things that you can employ for using data security. The main thing is that we use in our academia is RBAC, basically role based access control. So we just give the control of our optional data, or we give the control of our restricted data to someone based on their roles. So if it's a member, as you have seen on the GitHub, we provide a very specific restricted control, or basic control to our code base or data to a member on a very restricted scale. But that's not the case with the owner or a contributor or a collaborator on the GitHub. We provide a more open access to him by providing him the access to private repositories, or even like deleting the repository or transferring the organization or repository. So that's the difference. That's one case. We can use a RBAC, role based access control. We provides him the access to the data depending upon who he is. Okay. We can use some inscription algorithms that you might be familiar with also. It's AES and RSA. These are some like currently the industrial standards for inscription till now. But we are moving forward to blockchain authentications and blockchain inscription also now. But let's see how it goes. There is something called model interpretability. There are some tools that you can use, like I have mentioned here, Lime and Shap. So these are tools that you can use for model. which helps to identify which features are more important in comparison or in correlation to others. Okay, and you provides the access accordingly. Okay, there are some companies which use this DevOps or these practices very extensively. I've even talked to some persons in these companies, and especially Netflix. He explains me how Netflix uses A/B testing very aggressively. uh, it it provides the different set of models or services to different people, and it gets its feedback. So even if you are watching your Netflix shows, you might be the part of a A/B testing group, and they might be testing some model of recommendation for you, or for your group, or they might be testing some new feature for you. So these are some examples like Uber, Netflix, DoorDash, and these are some examples, but there are many. And currently, the open source world is dependent upon those DevOps practices. Okay. Now, best practices, I'll say the best practices are always needed whenever you are coding, whenever you are building something, because without a proper foundation, you always fall. So some best practices that I'll name, according to me, these are like most prominent ones, but you can search out the list on the internet and you find like 20, 50, 60, 100 best practices. So let's start with these are three things that I feel are most important. First is data versioning. In data versioning, what are you doing is, it's the part of retraining pipelines and retraining the model. Here you are collecting the data until and unless you have a sufficient amount of quantity of data, and you date stamp that data, and you feed that to retraining pipeline. So it helps you to version the data, version the models, and maintain a proper systematic way of retraining. So it can't be like very random. You can't specify the model retraining invocation just based on the data quantity. It should be based on the data versioning instead. These are some tools that I prefer for data versioning. It's DVC and Delta Lake. Is I think it's so much evolved from the last 2 years. So that's why I started exploring that also. Next is thing is model selection and tuning. Your model should be very much researched based upon your data. You should never randomly choose any model selection or tuning process just because you feel that might perform better. You should extensively research for that model. Some tools that I prefer are like Keras Tuner, and a tuner which is also provided by sklearn, so that also you can use. There is something called last practices. It's a saying basically, continuous model improvement. As I said earlier also, machine learning models are never truly finished. So the process of development or a learning model building never completes, just because data is not stagnant, data is not static. So this is one thing. Okay, we can start our Q&A. If anyone has any question regarding the above slides, you can ask me.
Thank you for that. And yeah, just remember, there's a few people asking about code. So very quickly, of course, it's totally your discretion, but would you be prepared to share some of the code from your talk today?
Yes, I'll share the code repository. Actually, I am a maintainer of an open source organization also. I've used all these techniques in the organization too, and I'll even share after the finishing of this session. They may ask on demand.
Okay. Oh, thank you. I've got a question actually. So
Yes.
Going back to Jenkins, that tool you use for CI/CD, are there any like nice intrinsic sort of tools that are built into it for monitoring things like drift or evaluation metrics, or does it all have to be coded with, say, like a Docker image?
Okay. So Jenkins specifically helps you to design your CI/CD pipelines, but you need that other additional tools to monitor your uh, ML model. You can attach there's a something called attaching of the containers. So if you are running your ML model in one container, you can attach a monitoring container which might have tools like Sentry. There's a called tool called Sentry. You can attach that container to your currently running container of ML model and use that to monitor and log the current working of that machine learning model or AI model. So CI/CD like Jenkins will not provide you the monitoring support. You have to use a different software like a Sentry. There's something Sentry, and you can use that Sentry software in a container and attach that container to already serving a served container. So that's how we do that.
Nice. Sorry, one more question. Is how does often would you say a model would need to be retrained to avoid drift? I know it's probably a bit of an open-ended question because it probably depends a lot on the data that you're dealing with yourself. But is there any sort of ballpark sort of approach to this, like how to retrain?
Actually, I'll say that there are not many tools as comparison to other things that we have discussed. It requires a developer or a researcher's input because data shifting or drifting, as I'll say, model drifting, uh, we have to give our input. We have to analyze that by ourselves. It provides a more uh, tailored approach so that we can handle better. But we have there are some tools, but that are not preferred. I actually try to manually analyze that stuff, how our data or model is drifting from our predicted or observed thing. How it is drifting, I usually do that manual analysis instead of relying on some tools because they are not so accurate in comparison to our human mind.
Yeah, that makes sense. Okay, I think that's all the questions. So yeah, thank you for coming along. Yeah, really enjoyed that. And yeah, just let us know about the repos and things. I'm happy to share that with anyone
Okay.
watching as well. So yeah, thank you very much.
Thank you.
Thank you. Yeah, also to mention that we have some codes from the previous talk that Alex did. We have a repo for Azure Function Scoring, which is available in the chat there. So yeah, if you'd like to see it, feel free to have a look at the link. We're going to take a short break, and then we're going to be back with myself and Anna, who are going to be talking about getting started with MLOps. So enjoy your break, and we shall see you in a little bit. Hello and welcome back. So today we have got the pleasure of having Anna with us. Hello, Anna.
Hi, how's it going?
Not too bad, thank you. So we are now going to start talking about getting started with MLOps. So this is Anna. She has been at Advancing Analytics for a long time now.
3 years, yeah.
3 years. Yeah. I've been here for about a year and a half now at Advancing Analytics. So yeah, over to you, Anna.
Yeah, so I'm Anna. I'm a Microsoft MVP. I was data platform up until recently. I have literally just moved over to AI because I do a lot around kind of MLOps, which is what we're talking about today. But historically, I was data platform. Background in like software engineering, so very codey, bit of a nerd when it comes to coding, but also really love anything data. And I've been doing it for quite a long time, so like 16 years, and been with Advancing Analytics for 3 of those, basically working as a consultant. So I'll hand over to Luke to introduce himself.
Hello, I'm Luke. So I've been in Advancing Analytics for a year and a half. I've sort of taken a little bit of a weird approach to becoming a data scientist. I started out doing something completely different to do with nuclear fusion, and then got bored of that and decided to go into data science. And here I am. Cool. So should we start with
Next
the agenda?
Slide. Yep. Right, so the agenda, what are we going to go through? Initially, we're going to talk about the why. So why MLOps, why is it important? Then we'll go into the model lifecycle, which bits we need to actually care about, different architectures around MLOps, Azure AI portfolio, and the Databricks and Fast API, so different solutions there that you can work with MLOps, and then deploying and monitoring model end to end. Yeah, so firstly, we'll talk about the why. So next slide. Yeah, so why do we need to care about MLOps? So first and foremost, productionization of models is the toughest problem for data scientists. So that is way back in 2014. It's literally just highlighting that essentially, yes, we've got loads of amazing models out there, but actually getting them into production, getting them into a state where we are comfortable with them and that they are doing what they need to be doing and we are monitoring them is really, really difficult. So 85% of big data projects fail 2017, and 87% of data science projects never make it to production 2019. Again, scary statistics. So there's a lot of problems around actually getting those projects out there into production, actually being used. So lots of great projects, but actually productionizing them is a problem within itself. And that is essentially where we get MLOps coming into the mix, and actually having MLOps as an area within its own right. And finally, Gartner estimates that between 60 and 85% of big data projects will fail, and contend that only 20% of analytics insights will deliver their intended business outcomes through 2022. So through last year, that was their prediction as to what was going to happen. And again, it's a scary statistic as to the amount of data projects we're working on versus the data projects that are actually getting out there.
All right, so I'm going to talk a little bit about the model lifecycle. So I'm probably not going to be able to do it justice in the same way that Alex did on the previous talk, but just going to run through the steps of a typical MLOps lifecycle. So first off, we have the explore phase. So this is when you're really just doing the fun data science stuff, playing about with the model, trying to get the best score out of it, doing all the nice feature engineering and stuff. After that, you have to do things like evaluation. So this is not just evaluating the model in terms of score, but sort of the business value, how useful it is to the business. And this is a really important step that follows on so that everyone's ready for this model and they have confidence in it. And then this is where it switches more to the MLOps side. So the development phase is not of the model itself. It's doing all the stuff like the building all the pipelines, the inference pipelines. And this is where a data or a machine learning engineer sort of comes into play. And you can do things like unit testing as well and setting all that up so that it's ready. Followed by packaging phase. So this is just versioning. So just making sure everything like the correct libraries are there and ready to go, and the correct versions so that you are ready to deploy. Once you deploy, you're in the deploy phase, and then you're ready for it to be monitored. So it's live, it's doing all sorts of stuff, and then you need to monitor it in the monitoring phase. And we're going to talk about this in a bit, but this is going to involve things like drift and evaluation, and it just goes in that cycle. It is quite similar to a normal software life cycle, but it's slightly different. Anna will tell you that.
Yeah, so on the kind of software engineering side, DevOps side, we have this magical figure of 8, which is the DevOps stream, where we write the code, we build it, we test it, we release it, we deploy it in operate mode, and then we go to monitor, plan, and back to coding again. So it's a magical figure of 8 constantly going around in the flow. And you'll see there the similarity in that we have on the left hand side with the MLOps lifecycle, that is also a flow constantly going around in the same circular motion. That in essence, we are constantly working on these solutions. We are constantly monitoring them, making sure they're performing as they should do. But the difference is that a software engineering project is not a MLOps project. It's not the same as working with a data science machine learning model. And that is a very clear-cut division, even though there is a lot of crossover between the two. So that's why it's really useful to show that these are very similar, but at the same time, they are fundamentally very different.
Yeah, and sort of to reiterate that point, software is different to data. Software is relatively static. Data is unpredictable. It can change. You can have new features come in. There can be a drift in the data. There's all sorts that can happen. There can be errors in the data that come in. Stuff you're not going to just have automated. So that's why they need constant monitoring, constant surveillance. And yes, you could probably do this all manually, but if you have loads of models and you're in a big company, it's very hard after a while to do this all just as manual steps. So it makes sense to have a proper MLOps lifecycle that is automated and you can just monitor in the background. So it is where data science is going, and it's a big part of it. So if you're going to have a production model, you do really need some sort of MLOps life cycle, even if there are some sort of manual like interventions that are needed in it. It is just good practice. So we're going to talk about testing, and over to Anna.
Yeah, so the big question here is how do we test this? So we're putting these models out there in production. You want to be able to monitor them and test them in the same way or the same ethos as when we're working it with kind of software engineering, so when we're working as data engineers as well. How do we do that? And very often, a good approach to this is actually what we call A/B testing. Now, A/B testing is used in software engineering and in other areas in technology as well. It's literally where, as we're illustrating here, we have kind of two different versions out there that we're able to have, like a challenger version and the existing version, and actually pitch them against each other. So we're having a challenger model, so a challenger machine learning model versus an existing machine learning model. Underneath there, we can see the exact same cycle that we were looking at before. And we are literally pitching them against each other and looking at the performance, at the results, and making sure they are doing what we want them to do, and that challenger model essentially is able to replace the existing model. And if that challenger model isn't scoring as well, or if it isn't meeting, for example, our SLA, so it isn't performing from a kind of a piece of software perspective, then we need to actually address that before it's able to, say, replace that existing model.
Thank you, Anna. So we're going to move on to drift and decay. So mentioned it previously as something that can happen. So what is drift? So drift, as you'd imagine, is just when the data starts to evolve, say. So you can have different types of drift. You can have drift where the features drift, so the variables change. You can even have a label drift where the output starts to drift away. Very closely related is predicted drift, where the true values drift. So there could be a change in pattern. You can also have things like conceptual drift, which is where the mechanism for whatever makes the score changes. So for example, you could have fraud model, but although something might be alerted as fraud, the mechanism behind what is fraud could change. Things like that. So there's a lot of space to actually monitor the models themselves and make sure that they when they drift to a certain degree, you can actually automate the retraining itself. There's a number of ways you can do that. There's some good tools out there. So Azure Machine Learning Studio is very good for this. It offers a lovely dashboard and a data drift detector, and it can automate emails to you when you go past a certain threshold. And it's just a nice dashboard to have. You can also go down the more coded solution. So you can use something like the KL divergence algorithm to monitor the distribution of changes. Personally, I quite like the Machine Learning Studio dashboard, but if you wanted to go down the coded approach, then there's plenty of libraries as well that can do this. Okay, so I am going to talk about feature stores. So I'd say they're relatively new in data science and MLOps. Before I go on to feature stores, actually, I should probably talk about Databricks, because a lot of these demos are going to be done via Databricks. So if anyone's not familiar with Databricks, I should probably give it a brief introduction. So it's basically a really cool notebook for doing distributed computing. I'm not doing it justice saying this, it can do more than that. So it supports multiple languages, things like R and Python, but also like Scala, SQL. And it's really good for machine learning because it has a lot of like libraries built in. So there's things like AutoML, there's a fully managed version of MLflow, which we'll talk about later. It offers endpoints, even Git integration for things like CI/CD, or if you're working with other people. And of course, it also offers feature stores, which is what we're going to talk about. So I'm sure there's plenty of data scientists on this call or stream, so don't worry about this bit, but just explaining what a feature is. So a feature, it's basically like a dimension or a column in a database. So if you look here, there's features here. So stored, product name, etc., number of sales, and you can even generate features from other features. So say if you had some coordinates and you wanted to see if they were lied within Bristol, let's say, you could create a column or a feature from the other features to say whether they're there or not, and that's feature engineering. And some of this can take a long time, and it's quite involved, some of it. So if you have multiple people working on a project, sometimes it can be difficult to track who's engineered what. And this is where a feature store comes in. It's like a nice way of centralizing the features, because in a way, like data is almost like the new oil. Well, like that's probably a bad analogy. They're like the new gold. Well, feature store would be like the Booleans. It's a way to make sure that you're keeping track of what features go into what model. And there's different flavors of it. There's different offerings. So Feast is quite a popular one, but Databricks also offers a feature store, which is what we're going to talk about now. Now, bear with me. I am going to set up a demo for you. So let's see if this works. All right, so I hope you can all see this. Perfect. Right, so in Databricks, if anyone's familiar with the notebook, you have to first load in the libraries. So this will be things like the feature store, feature table, feature client, etc. Then you load in the data that you're looking at. So this is actually just a data on crime data in Boston. So it's just looking at violent crime specifically. So things like simple assault, innocent assault, aggravated assault, all the not very nice stuff. We are going to use this data set and we're going to look at crime. So we're going to create the target variable. So violent crime, if these offense codes are within that lovely list, then it's violent crime. The next step is to create the database. So the good thing about Databricks is you can change each cell. So you can have SQL in one, Python in the other. So I'm going to use some SQL here, and we're going to create the violent crime table, which will appear here. So this is nothing related to feature store, but when we get to this part, we're going to start using the feature store itself. So let's initiate the client. And then what we first have to do is we create a table. So this is just the feature store table. So this can be blank, but what you need to include is the name, of course, the primary keys, so that these are like the indexing, and you can pass in the schema like so, and a description if you like it. So let's quickly create this. It takes a few seconds. All right, so we've now created the table. Let's write some of these features to it. So this is a demo, so I haven't really done any proper feature engineering or anything, but we have some features that we need to write to this table. So we can do that with the following command. Ignore the awkward silence. This will be ready in a sec. There we go. So now we've written it to the table, let's start using it. So this is where we take a model. So this is typical scikit-learn stuff that you normally see. So I'm just going to load in some models. So for anyone that doesn't know, scikit-learn is a typical machine learning library in Python, and XGBoost is a nice offering for a classifier. And it's taking a little bit longer than I would expect, but that should be running soon. Then we have to load in the data. Perfect. So we load in the data, and we're going to do a similar thing to what we did before, but now we have to initiate the feature store client again. But now we're going to start deciding what features we want for the model. So I've decided that this will be the features that we'd like to have for the model, and they are in the table. So what we're going to do is we're going to create a feature lookup, and it's going to look them up from this table of features that we already have in the feature store. And now we need to create a training data set from those features. So Feature Store offers a nice way of doing this. So you can use this function to do it. You pass in the feature lookup, the label, and then from this, you can make a data frame ready to use in training. I'm not going to talk too much about this bit because this is just typical data science stuff, but basically you're just training a model and you're training it here, and then you can score it like so. There we go. So you can see here, it's naively, there's better ways to score it, but you can get the score there. And the next step is to log that model. Now, I'll show you why we're going to the effort of doing this in a second. So once you've done the training and it's fitted, you can log the model like so. So you choose the flavor, you use the training set there, and you register it. Now, that shouldn't take too long. Right, so this, oh no, not quite done yet. There we go. So this probably seems like quite a lot of effort that we've gone to, but I should probably show you in the background what it's actually done. So if you notice here in the Feature Store tab, if we go to it, you've actually got the model now logged. So it's created a nice catalog of what's gone into the models. So if we look here, you have a link to the notebooks where it was generated, but you also have the features listed. So you have district, hour, all the ones that I wanted to use, and you even have ones that I didn't want to use that are listed. And it even indicates here what version of the model. So you can have multiple versions of the model, and it just keeps track of what's going into what and what version. And it's just, yeah, it's a really great way to monitor models, and it's definitely worth getting involved with. And you can see here the model is ready to use, not quite, but it's registered as part of the Feature Store. So yeah, Feature Stores are the new in thing, so I would definitely have a look at them. Right, let's go back to the talk. So model registries. Well, I did kind of already just show you model registries. They're just a nice way of centralizing the models so you have them ready to use, and you don't have to use them straight away. They can be automated, so you can just automate them into production, or you can have stages where you drag and drop them into production, or you can test them before making them production ready models. And you have different versions, and it's just a nice catalog, and it makes it very easy for serving them as APIs. So Databricks does actually offer this, which I'll probably talk about a little later. But yes, you can serve these using an inference cluster, for example. And talking about serving models, I can't really talk about that without talking about MLflow. So what is MLflow? It's a few things. So it's used for tracking models, metrics, parameters, and most of all, artifacts. So artifacts are the things that come out of the machine learning training. So they're the actual objects. One thing that people overlook as well is they're actually pretty useful for things like UDFs or grid searching. So I don't know if anyone here has done Databricks parallelization or UDFs. Well, they actually, it's not very visible what's going on inside some of these distributed nodes when you're doing the actual Spark commands. Well, MLflow can be a way to make that transparent, so you can actually log stuff using MLflow to sort of see what's going on inside the actual bit of script that you're using. So it's very good for that as well as a bit of a side note. And of course, the big thing is they are good for making REST endpoints. So if you want to serve the model, it's a really good tool for doing that. Okay, I am going to attempt a quick demo with MLflow. Give me a second. So yeah, this is MLflow. You don't have to use MLflow in Databricks. You can make it somewhere else, but the good thing about Databricks is it offers a fully managed service. So without it, it's a bit more fiddly to set up. You'll need like your own storage and Postgres, but it does that all for you. So the first thing to do is to load in the appropriate libraries, as you do here. So we've got MLflow, we've got some scikit-learn libraries, and we're just going to load in a quick data set. So this is going to be a data set on heart attacks. So predicting if someone's going to get a heart attack or not. So you don't have to do this, but it's a good idea to create an experiment. So it will create one for you, but ideally you want to make sure that each run is going to the same experiment. So you can do this by creating an experiment here. I've already created this, so it'll already exist, but this is what you'd use if you want to create the experiment. The next step, it's a good idea to get the experiment ID, and I'll show you why in a minute, because you need to pass it to another routine. But yeah, the next step is to get the ID. MLflow also has this nice functionality where you can auto log. So there's it doesn't have to be just for scikit-learn. There are other libraries, but it basically it takes all the hassle of logging all the metrics yourself and stuff. It can do a lot of that automatically, and even the artifacts. So I'm going to use the auto log for scikit-learn. So this is a very quick support vector machine. I'm going to use a column transformer. Ignore all this. This is sort of typical data science stuff, which I'm sure people have seen many a time. Just quickly, actually, I'm going to make a record of the scaling parameters that I've used for the feature scaling. So it'll come apparent why I'm doing this later, but I'm just going to write it to a JSON file, and I'm going to use this as an artifact to store in MLflow. Finally, going to train the model. And so it's actually already logged it using this way, but there is another way to do it. If you wanted to use it this way, you can also use MLflow start run and then pass the experiment ID to make sure that it goes to that particular experiment. And autolog is set up, but you can also manually log stuff. So quite often it will just log the training metrics, but of course you want the metrics from the test score. Really, that's the important metrics to look at. So if you want to log the metrics for like the R² score here, though it's a classification data set, so I don't know why it says R², but anyway, you can do that with log metric. You can even have routines that you can even pass multiple metrics here. So I'm going to use the eval and log metrics routine and pass in multiple metrics here. And this is just outputted as a JSON or dictionary. And then I'm also going to log the artifact created, which was the scaling parameters. So with any luck, let's run this. Right, so it's logged all those metrics and things. And just to quickly show you, let's go to the experiment. So it's logged it here. So this is sort of the nice dashboard for MLflow, and you can see here it's logged the metrics. So we have like the test score as well here, and we also have the parameters, so the things that actually went into the model itself. And you can even register models here and host them from Databricks as well. So Databricks does offer a way of doing inferencing straight from here, so that you can create an endpoint for APIs. They're also in the middle of bringing out serverless endpoints, which are going to be really cool. This would be sort of competing with things like Kubernetes or Azure Functions, as Alex was talking about. But if you wanted to use MLflow other than in Databricks, you could do things like download the artifacts from that particular run if you get the run ID. And I'm just going to quickly show you here. Let's say I wanted to do this. So I've downloaded the MLflow model itself. So I'm just going to show you very briefly, if you wanted to, you could use something like Fast API to host in something like Kubernetes. So with MLflow, you have to import it, of course. And Alex was previously talking about Fast API. So it's sort of taken over from where Flask was. It's just a really useful Python library for creating APIs. And I'm going to use it with Pydantic, which is just a nice way to validate the input into the code APIs itself. So when you receive your JSON packet, it checks for that it's in the correct format, etc. It's very customizable. And I did mention that about passing in the scaling parameters. Now, the reason I did that, you don't have to do it this way, but it was just to emphasize you can pass any artifact in. And doing this, you can set the scaling parameters for when you want to scale the data that comes in, because you remember fresh data isn't scaled and it needs to be scaled for the model. So this is a nice way of doing it using MLflow. And then you have to use MLflow to load in the library. It has all the correct library versions as well, so it doesn't run into any issues. And then finally, you have the code here. So all it does is it calls the model, does the transformation on the code, and it outputs heart attack or not. So to very quickly show you, I'm just going to host it locally. So we are going to look at using the following. This is what we want. So we want UVcorn, and we're just going to host it like that. So it's now running locally. And I'm just going to use Postman to give a very quick demo. So here we have a typical input for if someone's going to have a heart attack or not. So you have age, sex, all sorts of things that I don't really know what they mean. And if we post it with any luck, why isn't it showing? There we go. Wait, heart attack. So this person is going to have a heart attack, possibly. So we can change around with the parameters. So things like, so let's change like FPS, for example. No heart attack. So you can see here that MLflow has been used to train the model somewhere else, and you can host it and use it wherever you like. And yeah, it's a really great tool for that. So yeah, and get your FPS down to 0 as well. Right, so back to the talk. Here we are. So we're going to move on to architectures, which is now going to be on to Anna.
Okay, so architectures, when we're talking about MLOps and getting things into production, there's often a question raised about not just what technologies to use, but what architecture do you use? So traditionally in software engineering, for example, and I've been software engineering for quite a while, so for like 16 years, we have different architectures. So when I started coding, it was all what we call spaghetti. And then we started going to like a lasagna layered approach. And then essentially that was very monolithic. So you may have heard a lot around kind of monolithic architectures and how now we should all be using microservices for software engineering. There's always like the latest way of actually structuring your solution that is deemed as the most optimal way, the most efficient way of actually producing your, historically for me, software solution. But this kind of theory applies to anything kind of in the tech industry. So obviously kind of data science as well and models as well, getting those into production. How do you actually architecture that? So regardless of tech, what would you use? So Yeah, next slide. So there's been lots of kind of schools of thought around this, and one of them that kind of came out of that was a rendezvous architecture, and this was essentially from a book written in 2017 from Ted Dunning and Ellen Friedman. The rendezvous architecture was described and essentially picked up on by people in the industry and deemed as a kind of viable approach to essentially a solution to what architecture should we use to productionize models. Okay, so the rendezvous architecture, essentially we have the request coming in one side, and then that goes into the input, essentially it's input data stream. And then we have our models. So here's where we talked about before, having like A/B testing that challenger model versus your existing model. And then we score as a stream. And then we have our rendezvous process, which essentially eventually gives you a response. So this is very, very top level. If we start digging into this further for rendezvous, you can see how complex this could become. And this is essentially based on a kind of like a message consumer and producer model. So essentially what we mean by this is that, say, if you're using something like Kafka, you'd have consumers and producers. So you're using a message queue system in between all of your kind of scoring, working with your models, you're working with different topics within your queuing system. And this is very complex, and I'm not expecting everyone to look at this and say, oh yeah, I completely understand what this is doing. And this is essentially kind of the problem with the rendezvous architecture is the level of complexity. But what we've got circled there lastly is that canary model again, decoy model. So your challenger model and your current model, where we'd actually inject that in there, those different models, and work with them and score our data coming through accordingly, be able to see how those models are actually performing. So, and then we've got the challenge of when we're kind of moving from architectures, what technology shall we use? And this is just working with Azure, this example, this diagram. And this is from Advancing Analytics, aka the data science octopus, the data science ecosystem. There's a lot in here, right? And you're not expected to understand all of these technologies, use every single one of them within your data science MLOps solution. And so this is where people get a headache and they're like, well, what architecture do I use? If I use rendezvous, that's really complicated. Then which technology do we use? And that's why we're now going to move to a real world example. So this is essentially a real-world example, so something we actually did with a client, looking at this exact same problem. What was the solution that we came up with? And it isn't as complex as those last two slides. So what did we use? Initially, we used MLflow, and that was in the context of Databricks and using MLflow living on Kubernetes. So Databricks for the training models, MLflow for versioning and tracking of experiments, Kubernetes for hosting MLflow. And then we used Fast API, which Luke already took us through. So we had Fast API for our models to essentially be deployed onto, again, using Kubernetes. And then we're working with Cosmos to essentially store our model data. And this, I saw a question in the chat around how do you monitor model drift in production. This is one way of doing it, is we push all this data into a data store, and then we're able to monitor that data across time. So we're able to then see when we're getting model drift, for example. So what we did in this solution is we had a Databricks notebook where we could actually run that incrementally or even manually, and actually just look at the live data, compared it to training data, looked at how it was evolving over time and just made sure we didn't have any kind of any drift or anything going on, and that's essentially in production. So that's our entire flow for that client. So it's not using full rendezvous, it's not using all of those technologies, but it worked, it did the job. And at the bottom there, we can see how this directly relates to those beginning slides that we looked at, where we're looking at the different steps for MLOps that explore, evaluate, develop, package, deploy, and monitor. So using a handful of technologies, we've been able to get all of this into production, have that model in production, which was basically doing fraud detection. So it was very important, and we needed to have that reliability there. And this is all we needed. So getting kind of off the ground, getting this working wasn't as difficult as it could have been, or as some may have thought it could have been.
Cool. So going to move on to the AI portfolio. Let's see how much time we've got. So going to start talking about Machine Learning Studio. So Machine Learning Studio, it's a really good tool that's available in Azure for machine learning, not just building the models themselves, but as we've been talking about, MLOps. So hosting models, looking at things like drift, and looking at even like bias in models. So it's a very good tool for that. And in fact, there was an SDK with it that was V1, but now they've released a V2. And with that comes something called the Responsible AI Dashboard. And going to talk a little bit about this. I'm going to have to leave some time for questions, so I'm just going to talk briefly about it. But it is a very useful dashboard to use in your MLOps lifecycle. And it's sort of a mixture of all sorts. So it does bring in bias and stuff, but it also looks at model interpretability as well. I had to show you some screenshots. Unfortunately, I haven't got it working at the moment, but we do have some screenshots. So let's have a look. So you'll get the dashboard, you'll get it set up, and you'll get things like this. So it's a bit difficult to see on this slide, but what you can see there is a sensitive feature such as age. So unfortunately, you can't see it there. I do apologize, but you're looking at that sensitive feature. So you're looking at different ages, and you're looking at how the scores compare to one another. So this is to do with bias. So bias can be quite important with models, especially for sensitive features like gender or age. You need to look at things like error disparity. So if there might be a model that scores very highly because there's just an abundance of data, but then it might have a very, very poor recall, for example. Even though it calls a lot of truths, even though some of them might be true or not. And it's important to make sure these things are balanced, because that can really tell whether a model is biased or not. And there's plenty of libraries to do this. So there's one called Fairlearn, which is very good for this. And it even has an integration. I'm not sure about V2, but for V1, there's definitely a dashboard for bias, and you can use this library with it. And you can even do things like grid search, which do grid parameter searching that try to equal out these things. So you can look at things like demographic parity. So the sensitive features, the two groups have equal number of positives in them. You can have false positive rate parity, true positive rate parity. There's all sorts of options here. But yeah, this dashboard's really good just for visually looking at it. Also, we have things like looking at feature importance. So you can actually pick out each individual entry, and you can look at what governed that particular response. So again, I'm sorry, these are just snapshots and you probably can't really see what it says, but it's just listing the features that are important for what. Also, you can actually do things like what if with it. So this is quite cool. So let's say you have some sort of output and you want to tweak one of the variables slightly. So you might make it slightly less or slightly more. So you can do this within reason, and you can see according to the model how it affects the output. So you can do the what ifs basically. And it's a really great dashboard to show to someone that's not technical as well. So you might have a stakeholder and you have a model in production, and you can use it to show it like that. So yeah, it offers a lot of tools. I definitely recommend looking at the AL dashboard for MLOps. All right, on to Anna, that's going to talk about blue-green deployment.
Okay, yeah. So as part of the ML Studio in Azure, we've also got functionality for that blue-green deployment that we talked about before. So ML Studio gives you managed endpoints, and this is something that is fairly new. It was released last year, and what that means is that we can create ourselves a REST API wrapped around our model that then also gives us a whole load of functionality, including this blue-green deployment. And that means we could have 2 instances of the model, for example, that have distributed traffic. Here we're looking at 50-50, so we can do that testing. We can see how they are performing side by side without having to set up from scratch, using so like Fast API and using a whole load of other tools around that. We don't have to get off the ground. We've got tools such as this in ML Studio, and there are other solutions, other technologies that do similar things for us out of the box, where we can literally get off the ground, get on our feet, and actually look at this from a production perspective. So we do have, also worth noting, as part of this suite of tools in Azure, we do have the Python SDK v2, which simplifies the developer experience. And if you're not coding, there is the command line interface. It's just generally available at the moment and allows users to participate in the machine learning lifecycle without needing to learn specific programming languages. That is the DevOps stream that everybody can own it, essentially, having tooling out there so that anyone can pick it up and work with it.
Right, so onto a quick demo from Anna. We want to leave a little time for questions, but do you think we've got enough time to show the ML Studio?
How much time have we got, Luke?
Probably 5 or 10 minutes.
Okay, yeah, I can quickly run through it, and then we'll still have some time for questions. Okay.
Cool. If you share your screen.
Yeah. Okay, see that okay? Yeah. Okay, so we're looking at this blue-green deployment again, the exact same thing we saw in the slide. But what we can do now, this is my example endpoint that I already set up. Just tell that to go away. If we were to hit here, this is ML Studio, just reference if you haven't looked at ML Studio before. We're interested on this left-hand side in the endpoints at the moment. Literally making the assumption we've already got a model and we just need to wrap an endpoint around it. If you go to create, so if we were to go to create new and we were to create a new endpoint, and go to create. If we just go to the quick one here, it literally gives us a GUI that we can literally start going through, and it gives us all of those options where we'll be able to select the model and actually be able to say how we distribute the compute. So we will say, right, I've got a new model coming in, I'm going to distribute the compute, distribute the traffic, sorry, kind of 50-50, or you might want to distribute that differently. So you might want the new model only to have like 20%, or you might want it to have only like 10%, depending on how confident you are that this model is going to be a viable challenger model. But what we want to look at now, kind of given time constraints, is to actually go into our demo endpoint and actually start exploring what we've got as part of this demo endpoint that I've set up. If we quickly scroll down here, we can see we've got a Swagger endpoint. So you are getting Swagger as part of that, which is basically a REST API tool that gives you lots of documentation and ways of actually testing it out of the box. There's our endpoint that we can consume using whatever tech we want to work with. So whatever language we're working with. So you could give it to your software engineers and they could start consuming it. If you want to start testing it, you've got essentially an interface here where you can start doing that. So I'm just going to show you that here. Give me a second. So if I've just got some data already that I can throw in. If we hit test, starts giving us some results there. Hit test a few times. And then if we go to monitor, we'll go to consume in a second. If we go to monitor, we're literally getting information out of the box around this API that we've created. So we're getting requests per minute and we're getting request latency. You can see here at the bottom, it's giving us that blue deploy and that default deploy, which is like our green deploy. We can see how they're performing against each other out of the box without having to do lots of implementation of infrastructure. It's all already there. So it's that step towards kind of MLOps, getting it into production, having tooling like this out of the box that you can work with. And if we go to consume, it literally gives us some snippets of code for C#, Python, and R. Because it is a REST endpoint, if you're not using one of these languages, that is fine. It is the same as you to consume any REST API. But this is super useful because you can just grab this snippet of code, grab your authentication key, and be able to start working with it straight away. So I'll show you that in a second, but just before we do that, you can see you've got logging here alongside the monitoring. This does hook directly into working with the monitoring tools in Azure, so kind of log analytics, Azure Monitor. You are able to go in there and start working with it in the same way you would any other technology. So if you're not working with it yourself, anyone else in your team would then understand that and be able to make sure you're meeting things like your SLAs and that you're actually reacting to any errors or anything coming out. You've actually got that set up. That alerting and stuff like that is then easy to do because it's all already integrated in. And finally, can you see Visual Studio Code, or I don't need to present again? I think I need to. Hold on.
Present it again.
Yeah, that's fine. Yeah, that's fine. So give me a sec. Right, can you see that okay? Sweet, yeah, okay, right. So this is that snippet of code, that bit of Python. I've grabbed it, I've thrown some dummy data in that I used before in that window that we were looking at. I've got my endpoint, I've got my API key, which I'm obviously going to recycle after this because you've all seen it. And then I can literally run this bit of code and start getting the outputs there, which we'll see at the bottom in the terminal there. What's great about this is, again, you can give it to, you can work with it, obviously, but then also that you can give it to other people in your team, the data engineers, the software engineers. They can start writing maybe some unit tests around this, integration tests. We can specifically state which model we are working with. So this bit of code I've commented out here, if I were to add that back in, is literally just saying, just hit the default model, just test against that, which is really powerful when you're writing testing around this locally, that you're able to actually specify which model you want to start testing. So you can have a suite of tests around this on your kind of data engineering, software engineering side, as well as having what's out of the box in ML Studio. So you can get on your feet, as mentioned, really quickly with this. It's a really useful tool, and it gets you that step closer to actually getting your models in production. Obviously, this can be your tool of choice for production. You can literally get that API out there, start working with it, even if it's just for a minimal viable product or proof of concept. You can actually be working with it really, really quickly. So I'm going to stop sharing now.
Yeah, thanks, Hannah. So yeah, that's sort of everything we've got. So in summary, yes, I hope we've given you a flavor of the kind of things you can use for your MLOps framework or lifecycle. There's many different options other than just this. But yeah, Databricks and Azure does offer some really good tools to do this. We've probably got time for one or two questions. So we've got one here saying, how do you monitor data drift or model drift in production? There's a few ways you could do it. So ML Studio, the data drift detector, is a good tool to use. So you can link that to, you don't have to just link it to Machine Learning Studio. You could use Databricks to, for example, you can connect it to that, because you can use the SDK to do it, or if you really wanted to use like a Docker container, for example. And then you will have that in your production ready code, and you can use it there. Or alternatively, if you wanted to just code it yourself, there's plenty of libraries to do it. And then you can monitor it. The good thing about the data drift detector with Machine Learning Studio is it does offer email alerts. So if it goes past a certain threshold, you'll get an email, and then that will be the cue to retrain. And you can do it automatically in production, or you can just have more manual steps. It's entirely up to you. Okay, we've got a question here about how do you handle privacy concerns with sensitive data in a feature store? I'm happy to have a stab at that, or Anna.
All right. I was going to leave that one to yourself, because you're the feature store expert.
So, okay, with feature stores, if you are using the Databricks feature store, then it's within the workspace itself. So you might have security concerns about the workspace, so you might want it in a particular VNet and stuff. But in terms of when it's stored in there, it's fine. But if you were to use something external, maybe something like Feast, then there's definitely more questions around security. So if you wanted to use it in particular VNets and stuff, or use peering, for example. So yeah, I'm not going to pretend that I can talk to you about the ins and outs of security behind it, but that's in essence what you would look at when it comes to security. One more. So, is it possible to create good MLOps implementation without the use of cloud services on-premise systems? I guess you can do. If you had your own server running 24/7, there's no reason why you couldn't use that, and it can connect to other services. But benefit of the cloud service is that you don't have to worry about actually housing things. If anything goes down, then it's ready to spin back up in the cloud, and it just takes a lot of the stress out of it for you. But yeah, I can't see why you couldn't. How much time? I'm sorry. I think we're running out of time because we've got the next guest coming. But if there's any more, I can answer them in the chat for you. But yeah, thank you for coming to the talk, and thank you, Anna. And yeah, I hope you enjoyed it. Cheers.
Thank you.
Okay. So we're going to take a very short break, and then we are going to have Mauro, and he's going to be talking about things like Azure ML and ONNX. So bear with us. We shall see you in a bit. Hello, so welcome back. So we're here for the next talk. I am going to introduce Mauro. How you doing?
Hi, Luke.
Sorry, have I pronounced your name correctly?
Mauro.
Mauro.
Yeah.
Okay, so Mauro's up. He is a AI architect and also an AI ethicist, and he's going to be talking to you now about Azure ML, ONNX, and OpenVino. So, yeah, away to you.
Thank you, Luke. Thank you, everybody, for having me. Yeah, I'm Mauro Bennici, and now I'm working as AI architect and a Kaggle student mentor. But I started as developer, and I've been working in an era when my first computer was this one. So a computer completely disconnected. It wasn't possible automatically to save something. So we have just to create other tools to save our work. And there's not possibility to share information in real time. And also there is a lot of problem about the platform. If I take my code, my work to another computer, the platform was different. It doesn't work. It thinks that something that is completely very old, because now we have a lot of tools to share information with Windows, Mac OS, on Linux. And also we have the cloud. But it's not really true for all kind of AI project. There are some kind of AI project when right now it is not possible to share something, or it's not possible to use the cloud. So when the cloud arrived, we completely switched the way that we use the data science. Imagine just the data science is something that works inside a laboratory. The data were collected, they're analyzed, and sometimes they work only just on the machine of the data scientist, or just in a little cloud. There is a lot of software completely custom. So every company just brought their software to analyze their data. When the first cloud arrived, we simply switched our application to move to on-premise to a cloud. So this is like a one-to-one architecture. In this one-to-one architecture, okay, we have the databases, we have the virtual machine, so there is quite a replica of what we have on-premise on just our local machine. When it happens, the first kind of projects started. Also the customers selected us as company, as a freelancer, and so on, because we use the same architecture or the same platform. With the arrival of the machine learning services, something changes also for us, because now it is useless to maintain a lot of infrastructure of custom software to do something that is easy to do on the cloud. Is every time running app is possible to scale. And a lot of things like input data sources, or exporting something, or just clean up the data, it's easy to check, to control, to versioning. And so we start moving on these services. But sometimes we arrive the customer of my company, that just say, okay, we cannot use the cloud. Okay, it's not that I don't want, I cannot. Because they are bank, they are army, or they are completely disconnected like IoT in a forest. Okay. The hardware, or we can have some kind of hardware lock-in, because also the hardware sometimes is handmade. We create a hardware and we have to use something. But we are using, for example, Azure ML. So the dilemma is I have to say to the customer, oh, I cannot provide you the service. I completely run another unit to do this job. Or it's also possible to use both. So to continue to use Azure ML and provide our project, to the customer when they want, where they want. Also, because now a lot of companies have just built in many machine learning products and services, it's difficult to say, okay, we have to start from the greenfield. Sometimes they have models or they have system, and just they want to upgrade it and just to merge with other system. So, okay, we want the customer also. And what we can just check. Now we also have a lot of frameworks. So if the customer say, oh, I have a lot of codes on PyTorch, but okay, you are using Azure ML and you use TensorFlow with Keras, that's okay for us, but you have to import all our PyTorch. We don't want to pay to do the job again. Or also imagine when you read some paper, I say, okay, there is the GitHub code. This GitHub code is in Caffe. But internally, we know PyTorch and TensorFlow. So we have to rebuild everything from scratch. Later in the past, it was quite useful because it was fast. But with the list system, just to say a name, or the ChatGPT system, it's not so easy to say, okay, I rewrite and just I retraining. Just a single retraining on ChatGPT, it just means 2 or 3 weeks and a spend of $3,000 just to have the first epoch. So it's not more possible. But also, these frameworks change and introduce breaking changes. So if something is written from a TensorFlow version different from us, and different from the framework of the customers, also we have to work to adapt. It's a lot of time wasted. So this is an idea become in the OpenAI team. So in a lot of our system, we are not using the same binary, but we invented XML, we invented JSON, we invented other things just to allow this data to move to one platform to another and to be exchangeable. Also, the problem became, okay, this is a simple neural network. It's also because a simple neural network, we know that it doesn't matter the photos that we wanted to put inside our model. So it doesn't matter also the name of the label. In this kind is written in Klingon, a language that everyone talks every day at work, I know. It's the same is for the machine. The only things that we have to know to exchange a model to another is just the value that the model have inside the layer. With this idea in mind, they start to say, okay, I have a neural network. I can have the way I can put the input, the value of the output, the type of the output, all the layers value, the actuators, the evaluators, the activators, and so on. But at the end, what are this kind? It's code. It's code and math. It's only code and math. Okay. So it is possible to create a new project called ONNX and just made all these companies collaborated just to say that it's possible to export my model to ONNX. Just convert everything I need for the inference, so the way, the structure, the layers, so on, just in this new model, like a JSON on XML. The theory is the same. So the ONNX born, I say, okay, what we have to do just to be able to export this data? Okay, just simple tools. Just to say, I want to save on ONNX was the first start of the project. The second start is, okay, the second point is, but I want, just to be complicated, because it's so easy, not only use the neural network, but use all the other frameworks that we can share together. Boosting decision tree and like layer, SVM, Okay, but we said that this is also only math. Okay, if I want to create a project, that I want at the end to be exported in ONNX, I can just check the offset. So I have just to check this one. Just to be sure, because if I'm using just a TensorFlow and PyTorch, it's easy. But for example, if a data scientist, I created something from scratch, and just using something from Python, just to say, okay, I need an argmax, just have a little check before and say, okay, I can use this kind of, what is the version, what is the different? Okay, I use this version, I can use. So just because we have to thinking just at the beginning of the project that I want to export. Okay, just born to be exported. So the second idea is, okay, but if I see this kind of new model and this kind of ONNX, I can also implement a loader inside my framework. So if I create something on TensorFlow, I want to share to another data scientist, this I am use PyTorch. That's the same. We can check the offset. I can save the model. You can import the model. And the model will be imported with all the data that you need and it's completely written in PyTorch. And this is great. Just we have a way to share our models with different frameworks. Okay, but also I can visualize it. This is an example of visualization. There is completely framework independent, but there are inside the values. They are inside what they are. We are the ReLU, we are the Khushiyant network, we are size. So we can just look inside the ONNX, simply opening the ONNX. The other idea is, okay, now I have the ONNX. And I'm using this ONNX to do that, just to share one framework to another. But perhaps I don't need to fine-tuning or to open or to just import it to another framework. It's useless for me. Why I can have something just to run it? So it doesn't mean this is TensorFlow, PyTorch, Caffe. Who cares? I have the ONNX, I load the ONNX and just run it. So without all the wave, the libraries and so on, that is completely useless just for inference. And also say, okay, but if I want the ONNX and just for inference, I can save it just for inference or just kind of directly optimize it. So just don't use the float 32, but go to the float 16, or just use a quantization. Yes, now we have all the options that we are inside. So when we start now, and we are the ONNX runtime. Is one of the first frameworks that was just created by Microsoft and created by Microsoft. And now it's open source. A lot of other companies collaborate on it. And we have this kind of interfaces. So the idea is also to help companies that at the moment they don't have or they don't want to use or third-party tools, or they don't have the skills to use Python. Because, for example, my company uses Java and uses C#. If they want to use something create for us on Azure ML, and they don't want just to directly to expose them, but they have to own and just to expose internally, they have to learn Python. Or it's supposed it is in Python, or they write it is in Python. But the only things that we need is just to create inference. So this is our ONNX runtime page. You say, okay, my data scientist, the other unit, just created something on ONNX. Okay, now we will check later in a demo all the process. But I think I'm just a developer, and now everything is created. Okay, this is in ONNX format. That's okay. And also the data scientist just thinks in ONNX format. So they create something not caring about if it is running on CPU, on GPU, and so on. Okay, they create something on ONNX. Okay, I want to use it. I'm a developer, and in this case, we will see in the demo that we want to use something on Linux. It's written in Python. Is running on Intel CPU. It is running just on default CPU. Oh, it's okay. For this kind of library, just use pip install ONNX runtime. Okay, this is the main idea. Also, we will see that my machine today is a Mac. I want to use C#. I want to use the Intel CPU, and for this case, I use the default CPU. Oh, okay, don't worry. Download your ONNX runtime. In this case, I just install. I have a Visual Studio installed on Parallax on virtual machine. So this is Windows. I want to use also the C#. I want to use the Intel. Okay, just use the NuGet package for the ONNX runtime. So this is the main idea. All of these libraries just have the ability to load, import the ONNX file and run it. Just a simple code on C#. The ONNX runtime at the beginning started just to run something that was written on CPU and GPU and just to optimize. But with the new changes, we can also have, you see, a lot of platform. So I just can use it just to include on my iPhone or my Android mobile phone directly the model, other processor, and other kind of optimization. For example, directly the Azure preview is coming. So I can just use something that is just optimized to Azure. Or just I can export on TensorRT. RT is something just that is running for NVIDIA. And also we have the OpenVino by Intel. Also there are arriving other. But now that this is open, we can also use, for example, the AMD. And remember, this is at the end of the project. So I can start doing my job, and at the end, I can just share, run on all of this, the platform devices and frameworks, without retraining something or change some options, or that my data scientists know there is something to do. Just check this is something you're using is compatible, and that's enough. Also now they are arriving the idea is because why I have to create something using a lot of resources, because just we pay our GPU or cloud. If the idea is just at the end to have this running on ONNX runtime. So also it is possible just to train something directly optimized. Just to remove a lot of time from 5 to 6 times less. Because also the model is very, very, very small and optimized directly in memory, epoch by epoch. So now the other idea is, okay, we have the ONNX runtime. The ONNX runtime is good. But why ONNX runtime have to build from scratch the runtime? We can also collaborate. One of this collaboration arrived by Intel. Intel is possible just automatically. If we install ONNX runtime and we have installed OpenVino, they directly run, they recognize the OpenVino installed and they use it. This is useful because in OpenVino, if we are, for example, disconnected, like my company, that you imagine that all the machine learning models, the AI models, have to run in an Intel NUC disconnected. With OpenVino, we can use at the same time the CPU and the Intel GPU without saying nothing. We can use a multi-device cluster, we can use a multi-CPU, and we can just run. So something that is written to run directly for the hardware that we have. If I think that this is not enough, we can just have to see how they really works in Azure and what we have at the end of the process. So we can switch from my Azure. Here we are. So we are on Azure. We have the Azure Machine Learning Service. And now just I can create a new Azure Machine Learning. My time is the ONNX 2 service. Okay. The ONNX 2 service have all the configuration, but at the end, okay, I created, I configured, I need the payment, the health, the metrics, that's okay. But I have to launch my machine learning studio. Okay, we are. The first things to do is, okay, I want to create my algorithm here or just to import the algorithm of my customer. First things to do is to create the machine to run it. The creation is just a simple virtual machine on Azure, just to put our name, decide if you want a CPU or a GPU, and select what we want to use. Also, if we can customize, we can do everything just like the natural creation of a virtual machine on Azure. Same process. I created just one because it takes some time. Okay, this is an application created to run this kind of application. And have created my notebooks. The first things that I do is, okay, just if I don't connect the data lake, I can just upload a simple file. This simple file is just this kind of file. So I want to create a classifier. And this classifier, we have 4 features. So the length of the sepal and the width of the sepal, from the petal, the length and the width. And we have 3 kinds of labels. There is the variety of this flower. So we have the setosa, the versicolor, the virginica. That's easy. It's the most simple possible example. Okay, I want to classify it. This file. Okay, so I upload my ears file and just start to create my notebook. Just imagine that this is the work of the data scientist. So I just work as we work every day. So I just can start. This is the cluster that I created. I can have more than one. Just the environments. I can just create or use one of them. And okay, I want to install TensorFlow. This kind nothing strange. Now start to begin to install the TensorFlow to ONNX. If we can open more, I think is useful. Okay, TensorFlow to ONNX. So a library does say, oh, okay, you are using TensorFlow, and at the end I want to use this tool to be able to export the TensorFlow model to ONNX. Okay, just installed. Just to read the file. Just have an idea of what is, okay, plot 64. The file is working. Easily splitting, removing the label from the training data. We just converting our categorical label, so to say this is 0, 1, and 2 for the name. Split. So the training data to the test data. Now we are ready to create a very, very, very super simple model. So they arrive an array, just dense layer to 1000, 500, 300, a dropout, the activation of softmath, so really easy. A single optimizer, a check for the accuracy, and just the train of our model. Okay, so super simple. Just to have a check. We created that, we have that. Just we can run an evaluation just to say, oh, what is the loss of the test, what is the 93%, the images, just imagine normal work of a data scientist. We can have a test, okay, the test, this is the response says, okay, in this case, these three numbers, this is the category 0, 0, and 2. And now we are. Okay, my job is done. It is working. It is ready to go in production. Okay. But our customer said they wanted the ONNX format, or they have to run it on the nuke disconnected. We have to export. Okay, this is the important part. First, we have to create the specification of the input. So what is the input that ONNX have to trace as the incoming variable? Okay, this is the tensor spec format. Who cares what they have? This is we have 4 features. It's a float 32, and the name with a lot of fantasy I call input. Okay, when you want to save it there, that's okay. Okay, now TensorFlow to ONNX, convert starting from Keras. This is my model. This is the signature. This is the offset I want to use. So we see the offset here. So I know I decided that my framework, my customization, they have here the correct perspective in ONNX. So it's possible. And the output. That's it. I refresh. And this is my sequential one model. Okay. If I try to open it, inside I have this information. The version is 7, the TensorFlow, the product version. The input is done in this way. So the description of our network. And at the end, a lot of data. That is not easy to know. So the other idea is, okay, but if I hide all this information, we say I can create something just to have a look inside. Yes. One of these is called Netron. Netron is an opener for models, and in particular from ONNX. Also, I'm sorry, it's not possible to zoom more because it's not allowed. But this is the idea. This is the representation of our exported neural network. So we have the 1000, we have the ReLU, we have at the end the softmax, and here we have the same information. This is the ONNX, this is the ONNX, and the most important, this is the name of the input, and the type of the input, the output, the name, and what we expected. So in this manner, it's also possible to do not have a lot of documentation from the data scientist. So if I have the ONNX, I'm able to open the ONNX model and just to see, okay, I need this kind of version. The name I have to provide this one, this is the format, and I have to expect this kind of output. Okay, now you created this. Wow, wonderful, but what I have to do? Okay, in this case, what we have to serve? Oh, in this case, we also use Python. Okay, it was written in Python. I use Python in this Linux with Ubuntu machine. And we're just to start to say, okay, I have created a new one completely from scratch notebook and say, I want to install pip install ONNX runtime. Okay, I installed the ONNX runtime. Now just to import the ONNX runtime and the NumPy. Just have a look. In this notebook, I not installed PyTorch, I not installed TensorFlow, I installed nothing. I installed only ONNX runtime and the NumPy because it's included. But I do not need to install other things. I just expect to say the provider is the CPU provider. And just I load the sequential ONNX. So in this case, we call it the sequential one. That's okay. So we have the sequential one. And just say, okay, I have to the provider. So in this case, ONNX runtime just imported our model. Just to be sure, I can see what is the argument input. That this is the same that we have looked in the Netron. I say, oh, okay, I created the input fits. The input name is input. This is the value I want to check. And this is the float. This is the format. Okay, if I created the inference, I just run. This is the output feed, it doesn't matter. The input feed. This is my prediction. Obviously, I use an argmax and they say, okay, this is the category 0. So just is the power. I just exported something. I just imported. So in terms of how you say when you save a model, you have a lot of checkpoints. There is a lot of other stuff. This is nothing. Just this is. If, for example, I try to change this, okay, the category is changed. So it's not the first category. The first category is the second category. That's clear? Now say, okay, but I'm running also in Azure. My customer says they want to run in another platform, or they want to use another languages. Okay, that's okay. We can just move to Visual Studio on C# on Mac. I say, okay, this is a very stupid console application that we also have just to run this and to open our dependencies. In our dependencies, just all installed the Microsoft Machine Learning ONNX runtime. And now we have this. I'm using the libraries. I have an evaluate. Just download the sequential ONNX and just say, okay, this is the sequential ONNX with the post. I can do the inference session. It's the same we did in Python. We create a dense tensor. So a tensor, just the metrics used by the neural network. This is the type float. Is the new 1, 4. I just put same values. I convert it in the ONNX input value. And run. It's the same process that we did when we created it in the notebook, or that we created on notebook to serve in Python with ONNX. So at the end, we take the first input. This is a tensor of type float. We can an array, and we do an argmax. So we can just put on run, and now we have, in this case, the output is 0. If we start again and we change this one, they build again. Just create a new system. And just in our output, this is the output of type ONNX runtime disposable ONNX. There we have the same, the then 3D. Although we see on Netron. And now we have the inference type and the argmax. They say this is the category 2. The category is 2. So we create something on Azure. we tested on Azure. We downloaded it, we are running it on C# on Mac. And the same things is possible to do if we use Visual Studio. It's the same. I create a console application .NET Core 6. I installed the ONNX runtime NuGet library as suggested from the website of ONNX runtime. And I copied the same identical code that we run on Mac. Obviously, the path is mapped is different, but this is absolutely the same. And at the end is 0. If I change something here, what we really have is exactly the same. So the main idea is just, okay, I want to continue to use, don't worry. Dear customer, just export your model in ONNX without compression, without nothing, with everything inside. I just can import it and use it on my framework. I can just move with it and use it on my preferred cloud platform. And at the end, I can just export for you what you need. And the answer is 2. Exactly like when we run it on Azure and on our Mac. Because the idea is now that many customers, they are coming back to us and just asking, oh, okay, it was wonderful, the model that was working in production with a lot of servers, but we want also to run it on Android. Or we want to put it directly on an iPad Pro. And at the beginning, okay, you have to run everything from scratch, or I have to retraining, because I have to use their framework, or you have to use something particular, or I have to check what I'm using. With ONNX, doesn't matter. At the end, we have an ONNX. The ONNX have a runtime that support this kind of architecture. That's enough. Use it. Also, you can use OpenVino to run something on ARM. So there is the way that I'm using an ARM platform, an IoT platform. That's enough. If you are able to install the ONNX runtime, you can compile this. You can also export and run directly on IoT device your machine learning algorithm. So thank you for having me. If the time for question, I'm here for you.
Oh, thank you for that. That was really good. I enjoyed that. So I've got a quick question, actually.
Yeah, sure.
With ONNX, it looks really great for things like neural networks. Does it support, say, if you had say a TensorFlow model that was fitted into a pipeline, like a scikit-learn pipeline? Does it support like the scikit-learn sort of routines and stuff if you wanted to do maybe some imputation or something to the data before it gets passed to the neural net?
Yeah, it's used on scikit-learn. You can use, for example, a lot of algorithms. It's possible just to save at the end of the model on ONNX 2.
Oh, brilliant.
In the easy neural network, you can also export on scikit-learn and just reload on TensorFlow, or for TensorFlow to scikit-learn, just the neural network. But now I use it for everything. So decision tree is the same. So I can export, perfect.
Oh,
so because it's the way that I don't need to do something difficult.
My second question was also, say if you created a model like just a Python, like a TensorFlow model or something like you would normally. With ONNX, if you wanted it to be an edge model, does the conversion to ONNX, does it affect performance or at all, like the speed?
No, you can decide to say, I want the ONNX export as is. So it remain exactly the same, but the advantages is you can just use a lot of optimization. You can say, I want to use quantization, I want to use, I want to freeze some layers, I want to use to run and remove the layers that do not use for more. So you can really do a lot of benchmark without touching your model. Your model is a model, just you change something during the export.
Oh, nice. Oh, thank you for that. Don't think we have any more questions in the chat, but yeah, really enjoyed learning about ONNX, and yeah, it's definitely a tool I've been meaning to get to grips with at some point. So yeah, thank you for that.
Just for us, because for us it was something that we need to have.
Yeah.
Just imagine when you have a customer, I want to run on IoT device. You say, but it's not possible to fit it on an IoT device. We don't have the power.
Yeah.
Now in the ONNX we have it.
Yeah. Yeah, I use something, I think it's PMML in Python, but I probably should have gone down the ONNX route for it was for a C wrapper API thing. Yeah,
it's the same. But also because we have to integrate, for example, a model inside a medical machine. And all of this medical machine was written on C++. And they have a lot of problems just to use Python. They cannot use Python. So the first company have just to take it on Python and just translate on C# and just translate it on interop on a lot of work just to say that now we have also, if you use PyTorch, we can also export directly in ONNX. It's included. We can have save ONNX. It was the end of our project to export on the medical machine. On the other side, they just downloaded the library on C++ and say, load it, run.
Yeah.
That's enough. That's enough. Also for our data scientists, they have just to write a lot of documentation, just to say, oh, we changed this version of algorithm, we changed the kind of the inputs, we change. Now they don't do more this, because if they have the ONNX export, we can just open in Netron and we have this information. It's there. Yeah. So it's written, this is a float, the name is this way, we have to put that. If we put something wrong on the ONNX runtime, the ONNX runtime just stopped and say, yes, no, this variable have to be in this way, in this type of format. So that was a nightmare for big companies that have to introduce, for example, pipeline written in Python. They never use Python or don't have people inside the company to use Python.
Yeah.
And now we have the ONNX runtime. There is coming directly, not with the wrapper, but a library written in Rust. Pure Rust. So imagine the use of the memory to have the same model on Python and the same model on Rust.
Oh,
so
wicked.
The speed and the memory is completely another category. And just without touching the work of the data scientist.
Yeah. Yep. Well, you've certainly sold it to me. So yeah, thank you very much for coming in and explaining it to us. And yeah, if there aren't any other questions, yeah, thank you very much. And yeah, enjoy the rest of the talks.
Thank you, Luke. Thank you, everybody. Bye. Bye-bye.
Cheers. Take care. Right. So I hope you all enjoyed that. So next we are going to have Sarbini, who is going to be talking about responsible AI. That's going to be in 15 minutes. So enjoy the break and I will see you in a bit. Hello, everyone. Welcome back. Right. So next we have Sarbini. I'm going to introduce you now. How you doing?
Yeah, I'm good. I'm good. How are you?
I'm very good, thank you. Good to have you. So for our next talk, Sarbini is going to be talking all about responsible AI models with Machine Learning Studio. She is the Vice President of Visa Technology.
Yeah, Visa Technology.
Brilliant. All right. Well, thank you very much. And over to you.
Yeah, thank you, Luke. Thank you so much. And welcome everyone to this session. My name is Sarbini Maiti. I'm working as VP Data Science at Visa Technology. In today's session, I'm going to talk about a responsible AI model with Azure ML Studio. Before starting the topic on responsible AI, I just want to touch upon the Azure ML Studio, which will be used to create the demo dashboard, and we'll be using a couple of other Azure tools and framework that I'm going to discuss in the next few minutes. In our previous session, actually, we have seen great use of Azure ML, and here I'm going to talk about at the high level what are the different ways we can use Azure ML. Azure ML is an advanced machine learning which is giving us an end-to-end machine learning platform starting from the data collection, data analysis, build, train, deploy the model. To start with, when we are preparing the data, we need to do the data labeling. There exactly Azure ML can help us. Then comes the data preparation, data set, access, and also creating a security layer on top of that so that we can clearly create our landing zone, secure zone, and then we move into the processing zone. Second comes build and train model, which is the most important part. As well as we process the data, then we need to work on the data to clean the data. We need to process the data. We need to derive various features, feature engineering. There are a lot more stuff. For that, we are going to use the notebooks. So there are notebooks are available on the Azure ML Studio. We can use that. Apart from that, we can also use CLI and Python SDK through which we can build our end-to-end code. In our demo, I'm going to use the Python SDK to build the responsible AI dashboard using the notebooks and the compute. Second comes the automated machine learning. This is another option. We can create a no-code ML platform. Then the platform can be easily integrated with the Visual Studio and the GitHub. The Azure ML Studio is great because it also gives us a lot of drag and drop designer options. So if I'm not comfortable in coding, I can still use that by using the drag and drop designer feature. And for almost each and every stage, we get an UI option. So if I'm not going to use the Python SDK, I can use the UI features and I can build my pipeline, I can build the dashboard, and I can do that. Then compute instance, very important component and services. We need compute almost for everything, where we attach the compute instance depending on our requirement. The infrastructure of the compute instance, and if it is a smaller instance or higher instance, that totally depends on our use case, volume of the data, processing technique, modeling technique, whether I'm running machine learning or deep learning. Depending on that, we need to choose the compute instance. Azure ML is giving us an excellent experimental environment where we can run multiple models with multiple different algorithms. And after that, we can select the best model. And this is extremely important because most of the time, machine learning models are going through multiple cycles, and repetitively we need to run multiple algorithms so that we can get the best result. So they are exactly the experiment, and experiment jobs are becoming very handy. Open source libraries, there are a lot of open source libraries. Even in the previous session where we saw that, and there are scikit-learn, PyTorch, TensorFlow, ONNX, Keras, and there are so lot more. Then comes validate and deploy. So once model is ready, we need to think whether the model is the best model, how the model is performing, And then we need to think about how to deploy the model so that model outcome can be consumed by the end user. So managed endpoint, through which we can manage the real-time endpoint as well as batch endpoint. It's not endpoint for the batch transform jobs where we can predict a number of records in one shot. The model can be, there are several ways we can use the Azure ML Studio. Let's say I have built the model, trained the model and prepared the data, everything on the Azure ML Studio, but I want to deploy the model in a completely different cloud or on other on-prem device. That can be done easily with the hybrid and different multi-cloud options. Pipeline and CI/CD. So we can build the pipeline starting from data preparation to deployment using the pipeline options. In my demo, I'm going to use the model Azure ML pipeline option when I'm going to build the responsible AI dashboard. We can do the optimize, we can use a lot of optimized technique in the same ML Studio. There are a lot of pre-built images are available through which we can quickly build our model. Model repository, another important part where we can register our model, and anytime we can go back to the registry and we can download the model whenever we need. We can manage and monitor the model, and once model is deployed in production, the entire MLOps pipeline easily with the Azure ML various features. Some of the features are monitoring and analysis feature, policies, which comes under some of the part actually coming under the responsible AI framework. Data drift, we measure the data drift when model is deployed in production, and we need to check whether my model is running equally well as I deployed. That point of time, we need to check the data drift, concept drift, and then various metrics are actually calculated in runtime or during the production run and compared with the previous run, which were used to baseline the model. Security, another features which is extremely important for responsible AI framework. Error analysis, will be covering that here as well. Cost control is quite important in entire cloud system. Whenever we are running any workload in cloud, we need to control the cost. So there are cost explorer, cost analysis dashboard, and we can check cost by resources, cost by different zone, cost by different services, and we can also create budget alert, cost alert, and we can and use Azure ML Studio with all the different services. Auditing is important. Again, it's kind of a part of responsible AI and governance framework, where we need to audit the data lineage, the model which are running in production, and different artifacts which are associated with the model. This is a quick snapshot how Azure ML Studio look like. Once I will switch to the Azure Studio, we'll take a look at it. So this is a kind of high-level Azure ML Studio. On the left-hand side, all the different services what we are talking about are available here, and we can use them just by clicking and start working on it. Okay, next section we'll talk about responsible AI. What is responsible AI? Responsible AI framework is basically dependent on all the 6 different topics: fairness, reliability and safety, privacy and security, inclusiveness, transparency, accountability. Let's look at all the topic one by one, and how are you going to use the Azure ML to implement all those concepts in the real production or real scenarios. What is responsible AI? When we want to talk about it at a high level, responsible AI, commonly known as responsible AI, sometimes we call it even a lot of time explainability and a lot of other stuff, but at the overall concept is responsible AI. Everything else comes under this bigger umbrella. This is an innovative methodology that prioritizes the safe, trustworthy, and ethical development, assessment, and deployment of AI systems. So we can see responsible AI development starts from the stage 1, when we start talking about data collection, data sourcing, data ingestion, data analysis, and it goes through model development, post development, when we validate the model deployment in production, and after that, when model is running in a production in an operational mode. So each and every stage of ML life cycle comes under this responsible AI framework and practices. And we need to build all such techniques in this entire pipeline. That makes this entire concept quite complex. If we want to build such system in an open source platform, it actually needs a lot of different tools and technologies, and it becomes quite difficult to manage. In that way, we'll see how Azure responsible AI platform help us to build everything in one place, in one dashboard, so that different stakeholder can go and check the output. Responsible AI output may be different for different stakeholder. Let's say I'm a data scientist. As a developer, my interest would be different from the business owner or the end user. Let's say it's a healthcare applications where doctors and physicians are using the system. For them, the outcome and interpretation of outcome will be completely different. So that way, it is extremely important to understand the use case and the end user, and then integrate the dashboard along with the pipeline. Why it is required? Okay, so when we are building the model, it is actually taking a lot of critical decisions which are impacting the many human lives and a lot of critical mission critical applications. These decisions can be guided towards more equitable and beneficial outcomes. Thus, keeping the system's purpose and human interaction in mind, we need responsible AI. Azure RAI. RAI is responsible AI. This is a kind of framework which is built in Azure and which is well integrated with the Azure ML Studio. And then it is going to give us a fantastic dashboard. Azure RAI dashboard is dependent, even actually it is built on all 6 principles, what we just talked about: fairness, reliability and safety, privacy and security, inclusiveness, transparency and accountability. What is fairness? AI system should treat everyone fairly and avoid affecting similarly situated groups or people in different ways. For an example, when AI system provides guidance on medical treatment, or in banking application, let's say it is going to take a decision for loan applications or employment for any HR system, they should make some recommendations to everyone who has similar symptoms. Thus, they have to produce the outcome equal for all the sensitive groups as well as all other groups. The fairness talks about all the sensitive attributes or features like gender, ethnicity, or financial conditions. This kind of attributes should not influence the prediction of the model. So outcome should be equally same for all the groups who are coming under that particular cohort. How are you going to achieve the fairness, inclusiveness in Azure machine learning? In responsible AI dashboard, the fairness assessment components are enabled for the data scientists and developers to assess model fairness across all the sensitive groups, like as we talked about, that gender, ethnicity, age, and other characteristics. And again, it depends on various use cases for various domain. Let's talk about reliability and safety. To build trust, it is critical that AI systems operate reliably, safely, and consistently. These systems should be able to operate as they were originally designed, respond safely to unanticipated conditions, and resist harmful manipulation. This is extremely important. The manipulation. this is a statistical model. Lot of time, intentionally, even unintentionally, the model can be biased and it can create the outcome which may not be good for certain groups. How are you going to ensure that reliability and safety features are available in Azure Machine Learning? The error analysis component, what we are going to see in our demo, in this particular dashboard, enables data scientists and developers to get a deep understanding of how failure is disturbed for a model. So it's kind of error metrics and error statistically calculated value can be shown clearly on the dashboard for different groups. Then identify the cohorts of data with a higher error rate and then analyze it further. If we constantly see very extremely higher error rate for a certain groups, we need to check it further. These discrepancies might occur when the system or model underperforms or specific demographic groups or for infrequently observed input conditions in the training data. And this kind of error can be injected at any stage of the ML life cycle. So this is extremely important to detect them before model is deployed in production. Transparency is extremely important. Model prediction and outcome is clearly interpretable by the end user and other stakeholders. It's very critical that understand what is the prediction outcome. If the particular model is saying this particular application should be rejected because the risk of fraud is quite high or its risk is greater than 80%, the operation team should know why the particular application is flagged as fraudulent transaction. There might be 2-3 features which are dominant there, but we should be able to understand. Black box model predictions are quite dangerous because we don't know why the model is taking such decisions. Improving interpretability requires stakeholder to comprehend how and why the system is taking such decisions. Because if the decision factors or predictors are not aligned with the business, they can take a quick action and it can be fixed before model is deployed in production. In Azure Machine Learning, the model interpretability and counterfactual what-if components of the responsible AI dashboard enable data scientists and developers to generate human understandable descriptions of the predictions of a model. We'll see that in the demo, how Azure ML dashboard help us to find out all the important features for the entire model as well as for each and every prediction. We call it global explainability as well as local explainability. Privacy and security. AI systems make accurate and informed predictions and decisions about people using data. AI system must require transparency about the collection, use, and storage of the data because data is everything for an ML system. So it is extremely important to protect the data, encrypt the data, and use it for the model because model cannot run on the test data to generate the production outcome. So we need production data, but we need to make sure data is protected. In Azure Machine Learning, we can see all the Azure managed security framework, security features which are already enabled. So we can restrict the access of the resources, different services, depending on the user account or user group. We can restrict incoming, outgoing network communications, encrypt the data in transit and at rest. We can scan the vulnerabilities. We can apply the audit configuration as per the organization policies or any external policies which are applicable for that particular use case. Accountability. The people who are designing the system must be accountable. AI systems are not the final authority on any decision that affects people's lives. We should bring all the stakeholders on the same page so that everybody can understand their accountability, responsibility when a particular AI system is being designed. And that can be, how are you going to achieve that in Azure machine learning? So the end-to-end data lineage, the end-to-end MLOps framework, which are deployed in Azure ML Studio to protect the model. We can register the model, the package, the model is deployed, all the versions of data, all other model artifacts are well secured in Azure ML Studio. So at any point of time, if anybody wants to audit or go back to the previous stage, we can easily trace the particular prediction, why it is happening, by which model, or on which data set. Okay, so let's talk about the dashboard, which is deployed in Azure ML Studio. In the responsible AI dashboard, we'll see two important components or two major components: model debugging and business decision making. At the model debugging stage, we will use these components as written here: error analysis, data explorer, model overview, fairness assessment, model interpretability, counterfactual what if scenarios. For the decision making, we'll be using the causal analysis as well as counterfactual what if process. Now in the Azure ML Studio, the dashboard will have two major components. One is RAI, Insights Dashboard Constructor, and the tool components. Under the tool components, we'll see all the various subcomponents like add explanation to RAI Insight Dashboard, causal analysis to the RAI Insight Dashboard. We'll be adding counterfactual analysis, error analysis, then gather the insights in the dashboard, and then we'll build a scorecard which can be downloaded from the dashboard to our local device so that we can use it as the report of this entire responsible AI framework. At the model debugging stage, we are going to identify through error analysis and fairness assessment. When we move on to the diagnosis phase, we'll talk about model interpretability, counterfactual analysis and what if scenarios, exploratory data analysis, EDA. Mitigate. In the mitigation, we can use a lot of unfairness mitigation technique. There are quantitative measurement, there are qualitative measurement, and we are not going to touch upon this mitigation part here in this particular session, but that's a kind of another area. It's very important to know how to mitigate the bias and other errors which are detected in this entire life cycle. Data enhancement also is a part of the mitigation. In the decision-making stage, we are going to use the data by EDA. Inform actions are taken by using the causal inference technique and counterfactual analysis. We'll see that in demo. Okay. For the demo, we are going to use the responsible AI components to assess a regression model and a decision tree model trained on diabetes progression data. Next, we'll work through the API calls necessary to create a widget with model analysis insight. And we'll see the final dashboard where we can visually interpret various features, what we just talked about. So here is the high-level plan. We are going to launch the Responsible AI Toolbox. We'll train a model. We'll create the model and the data insight. And then we'll take a small example and we'll go through the dashboard and see what are the different kind of informations are available for us. This is a very high-level code. I'm going to switch to my Azure Studio. So this is the Azure Studio through which I have just launched my Azure Responsible ML Studio here. Once I launch Studio, I will come here on my Azure ML Studio. On the left-hand side, we can see notebook. Then we can have the data component, pipelines, models, endpoints we are not going to use here, and the compute. So I have already launched one compute here, RAI demo, which is running. because it takes a few minutes to launch the compute. And then I have opened the Jupyter Lab here. So this is my Jupyter Lab where I'm running all the code. In this particular demo, I am using the Python SDK method through which I have launched the entire RAI dashboard. Before moving on to the RAI dashboard, let's quickly look at this code little bit. In this particular code, we have used our different mode, and then let me quickly go to this. Uh, this is the Azure AI ML library, which is required to use the Azure ML Studio services so that we can build the model, we can train the model, and we can launch the pipeline. Here I'm accessing the data. This is for the simplicity, this data is already available in the Azure Studio, Azure library, and in the scikit-learn framework. I'm just using that diabetes data. Let's take a quick look at the data. This is a simple numeric data. And here we can see the score, like whether a person risk of diabetes is kind of high or low, and the score is already available depending on age, sex, BMI, BP, and couple of other metrics. We are also going to use various libraries which are used to launch responsible AI dashboard. Before that, we are going to use one typical asset type. This is ML table. To launch the RAI dashboard, it is important that we are using the ML flow training pipeline. We are using the data type as ML table, and we are also using the scikit-learn framework for model training. To make sure, we have also used the ML flow pipeline here. And then this is the type of data we are using. And now we are trying to build the model training pipeline. In this training pipeline, we are using two components. One is the actual model training component, and then the registration component. Why? Because RAI dashboard will be enabled for the models which are registered to the model registry, Azure ML model registry. So if we look at here, you can see once I run this particular training part, this codes are available in the Azure ML sample GitHub. So we can see this is going to use the pipeline, Azure ML pipeline. And here also we are kind of using all the ML flow features, because that's another important requirement for this RAI dashboard. And then once this is done, the pipeline will be built here. And once pipelines are available, we will be able to see that here under the pipeline. So if I go here, we can also see the models. So here you can see there are two models I have built. One model is built to show the error analysis. Another model is built to analyze the final decisions. So if we click the model, we will be able to see all the details about the model. So name of the model, and important factor is this one. So if the model type is custom, we will not be able to use this technique, because then we have to create another Python wrapper on top of that, so that RAI dashboard can be integrated with this model. So easiest way is to use the ML flow training methodology so that we can create a ML flow model. Second important is this flavors. So these flavors you can see is sklearn flavors. So we have to use the sklearn methodologies to, so that sklearn model libraries, so that we can create the model which is compatible with the RAI dashboard. Once models are created, then it will trigger the pipeline and model will be registered. Now model is registered, so we are able to see them under model. Now pipeline, if we click on the pipeline, what are you going to see here? So pipeline will tell us how exactly this entire flow is being executed inside the ML Studio. So I'm just trying. Okay. Yeah, it's kind of now small font. Okay. Okay. So here we can see these are the various steps. Actually, they are all are triggered together in parallel. And then this is the RAI inside dashboard constructor. Now here this constructor is triggered because we have already used this RAI dashboard pipelines and RAI dashboard libraries. So apart from ML flow, once pipeline is ready, then pipeline will automatically trigger the RAI part and model on the model which are already registered. So here you can see the RAI inserts are getting generated. All the insights will be available on the dashboard side. So let me go back here. So this is the pipeline. We can see each and every step. When it is running, when generally it runs, it generally keeps on uh, changing. It changes the status of each and every stage. And finally, we can see all are green, means all are completed successfully. And then the final scorecard, dashboard, all are created. Once this pipeline is done, we can monitor it and we can see everything is created properly. Then we can go back here. Again, we can click on this model and we can click here on this responsible AI part. So it should open the responsible AI job, which was created by this pipeline. So here is the report finally created. Now, interesting thing, you can see there are two tabs are selected here. That means error analysis is done in this particular code and counterfactual analysis are done. In the this is the model diabetes regression model. There is another model what is created here. Sorry, here in the model side, the decision model. So this is the same way. There is another code to create the decision model. Only thing is different in both the side. The decision making part is incorporated here. So if I again go there in the decision model, and I can also open the responsible AI dashboard. So right now I have two dashboard, and if I click on this, I have opened the dashboard here. So this is the one dashboard where we are showing regression model and the error analysis. And on the other model, we can see the decision making part. Let's look at the dashboard one by one. How does it look like? So in the regression model, you can see what it is doing. So if we look at this, the use case, the same thing we have already talked about. So let's take an example that the diabetes progression scores, which are predicted by the model, are used to determine medical insurance rates. So if the score is greater than 120, there is a higher rate. Now, let's suppose there is a patient whose score has come out to be 27 to 271, which is more than 120. And definitely his insurance rate has been increased because of that. And the patient wants to know how can he or she control the score within 120 so that he or she can control the rate of the insurance as well as they can reduce the risk of being diagnosed as diabetes. On the other side, insurance company would be interested to know what are the different predictors are important when they want to generate the score of a particular patient. So everybody has their own way to interpret the model as well as objective by looking at the model outcome. So here you can see when we'll go back to the model, we'll see that again. But quickly here, once we'll select the patient, let's say the patient index is 43. We can select that 43 index here and we can create a graph, age versus predicted factor. So you have predicted Y is score, risk score of being diabetic patient. And then we can see the predicted value is dependent on age with this. Now, this is not the actual age. This is a statistical measurement which is created by the RAI component. So there are different algorithms as well, like SHAP value or Lime. So all the statistical measurements are attached with the age, which is telling us how important is that particular feature or age, or how influential, what is the impact of that particular feature on this predicted value or the score. So it's just a number, it's not the actual age. But looking at it, we can see, so this particular Y value, now we have to see how can you control this Y for this particular patient whose index is 43. Now we'll see there is another graph we can generate for that particular patient, which is telling us there are two features, S5 and BMI, are quite important and predominantly impacting the output score. So if they can control these two features, that would help them to reduce the score factor. Now, let's look at another entity here or stakeholder. It's a doctor. Doctor wishes to know how to reduce the progression of diabetes in the patient, in her patients. Now, this can be explored in the causal inference component of the responsible AI toolkit. So, in this causal inference component on this particular dashboard screen, we'll see the aggregate causal effect tab, which will tell us how the different features are related to all the features in terms of different statistical measurement. So here we can see we are measuring the effect estimate, standard error, z-score, p-value, confidence interval, and then confidence interval upper and lower, both the values are there. With this technique, we can clearly see all the numbers, but it is also giving us a graph which tells us how this particular feature, let's say again we are looking at this causal effect point and S2. Let's look at this particular feature, S2, BMI and BP. I'm looking at the S2. If we look at this expand or the distribution of this particular feature, it appears that increasing the value of S2 by 1 unit, we can increase diabetes progression by around 684 units. So it's kind of heavily impacting the output score. And this will help the doctor to look at few important parameters through which they can control the patient's health. So eventually this model is impacting the patient care, and it's quite crucial for the doctors to know if the model is taking some decisions, why it's so, and how can it be controlled. Now when we look at it, we need to check there are certain error factors which are generated by different cohort. So we look at it in the demo again, but let's analyze it here a little bit. So once we'll go to the error analysis tab, we can traverse to a different path of this particular decision tree. And for each path, we can generate, or we can actually see the different error factor which is generated for this particular decisions. And then we can select which cohort is giving us the maximum errors and how to analyze it further, because probably that's a particular cohort might be victim of any kind of bias. Bias can be injected by the data, or bias can be injected by the model, or data sampling technique, or anything. So that particular cohort will be coming under review. But yes, we can clearly see which cohort is generating the maximum error. So let me go back to my Azure dashboard now so that we can relate all the theory, what we're looking at. Okay. So this is one dashboard where we are talking about the error analysis. So here, this is a tree map, which is good because it clearly gives us the tree effect, what we can see clearly. Let's say I'm clicking this one, and here, this is one cohort. And then I'm clicking here. So this is the path is generated. For this particular path, we can see the error coverage it's just a coverage value. It will additional information on error coverage, probably you can see here, but it's just covering 30% of the error here. Important is this, the mean square error. It's 1848.42. And it's also kind of visible here for this particular node and the path. But if I click on here, so I have created another path. Then this is the path. Age, again, this typical value is less than 0.02. Here, it's now picking up another features, which is greater than minus 0.02. And here we can clearly see the error value has been increased. Now, if I look at here, so these are the 3 nodes we can follow. Here also kind of 2000. So we can see here, we can see the error is the list error is recorded. But this particular part is quite important to see because this is generating quite a big number. I mean, it's a large error. It's not a good thing to go with. This is currently for all data cohort, but we can also use our own cohort because right now I'm just using hardly 89 records. So I'm fine with this. But when you are dealing with millions of records, then definitely we have to break that in different cohort, and we can create the cohort depending on predicted value, and then we can create the operation like greater than, less than, and we can generate that particular value, and then add filter. It will reduce the number of rows, and we can create multiple cohorts for that purpose. Okay, let's look at the model overview. So once we have done the error analysis, now we can also look at the model, how the model is performing. This is also important. You can see this is for a particular cohort. This is the sample size. This is the all data, 89, 32 out of 29, 89 are used here. And what I'm seeing here, as it is a regression model, so you can see the mean absolute error, mean squared error, mean prediction. So all the values are generated here in a nice graph. And we can also check the target distribution. So our target is the predicted value, and we can also choose the target. So this is the predicted value. You can also check the true value, or we can also see that, let's say, error. I want to apply it here. So I can see how the temporary cohort and all data are performing in terms of error. And there is some metrics visualization as well, and where we can see how this particular metrics, mean absolute error, is recorded against the temporary cohort, what we have just created, 32 records and all data. Data analysis, that generally we also do in the previous stage, in EDA stage, but here we can quickly check how the different data values are recorded. Then comes what all? Okay, feature importance. This is another important aspect we check. Once the model is generated, what are the top features which are impacting the model prediction? So, but here it is, you can see this is the aggregate feature importance. So on overall model, how the important features are sorted. So you can see it's kind of for S5. So there are two things. Temporary cohort. So as we have created another small cohort of 32 records, so always we are seeing this comparison here. So temporary cohort is the blue one, and this is the all data. And this is the important feature S5, BMI, then becomes BP and 6. But they are quite low in terms of the impact. But yeah, these two are prominently, they are quite important features. So you can also create some dependence plot. Okay, let's say BMI, we are seeing it's quite important in the temporary cohort, or we can also create it in the all data. So we can see how this particular, so here we are creating how this particular feature, BMI, is, the value of the BMI is kindly, I mean, it's related to the feature importance of BMI. So as the BMI value will increase, we can see the importance is increasing here. From here to here, the importance are increasing quite sharp. But here in the lower value of BMI, the feature importance is actually low. And even BMI is greater than 0.075, then also is kind of quite stagnant, the feature importance. So this part is quite important for this range of BMI. We can see feature importance are increasing as the BMI increases. But it will be different if hopefully it will be, if let's say the S1 was another important feature. Look, the entire pattern is quite different here. So in this range, this particular range, the importance is going down if S1 increases. But here it's quite straightforward. It's quite straight line, constant value of S1. When S1 value, actual S1 value is low, the importance is same. So even if you change the S1 value from one unit to another unit, it's not going to impact the model prediction. But here it will impact the model prediction quite sharply. So we have to be careful when you are taking such decision. Counterfactual analysis, what we are talking about. So we can select a data point. We are talking about 43, but it might be a bit here and there different. So let's say I'm taking another one, index 52. So this is the patient I'm looking at, and it will give me the raw data. But here we can see this is the patient 52, and this is the age values coming in terms of impact. And then I can see this age, and here it is important. It is telling me, look at S5, not S1 or BMI. For this particular patient, S5 is important. Then we can go back and we can check how can we can control S5. So probably we can check here. Let's see S5. Okay, S5 looks like the similar pattern. So this particular region, if you increase S5 a small quantity, it will increase the importance a lot. But here there is no such impact. Here also, if we increase S5 after certain value, it doesn't have any impact on the prediction. So that way we can take a confirmed decision about our action, what we are going to take as a doctor, or anybody, any physicians wants to take such decision. Now let's look at the next dashboard here. So we are talking about, we have already gone through the model preview, is the same data analysis, but yes, counterfactual analysis is there as well. Causal analysis. So here we are doing some causal analysis as well. So aggregate causal analysis, as I was talking about in terms when doctor was trying to find out what is the root cause of this particular issue. That's quite huge impact on the output prediction. This particular S2 features will be quite important. Now there is another aspect. So if we just go here, model explainability. So that model explainability we can also achieve with this. This is not right now integrated with this dashboard here, but we can clearly see it here. So as I was talking about, it has different features, model performance, that this is also available on the RAI dashboard. Dataset Explorer also available. Here we can see this individual feature importance and the aggregate feature importance. So if this is one probability where it is coming as, let's say, rejected or age, and in this age value we can see for this particular row, let's say 383, the row number for this particular record, it is giving me certain pattern. Even we have seen that as well in the causal analysis graph. And this particular user, we can see certain features will be important. But the moment we'll change the sample number, we may see a different set of features will be important. So this is important if we do record by record prediction and we want to take action for each record, then this individual feature importance will be quite important. And that can be integrated with the Azure dashboard as well. So here right now it's not integrated, but yeah, we can, if we integrate that, so that part will be available here under explanation tab. So for that, there is another set of libraries and code which will be required, which will launch the explainer here, and it will build the dashboard here on this particular tab. Otherwise, we're good with this responsible AI dashboard here. And I think with this, I am kind of done with my talk. And another important thing is scorecard PDF, which is generated when we generate the dashboard, can be downloadable, and it's a simple, nice PDF. What we can see, you can see diabetes disease progression measure. It's giving me the date, time, name, everything, the target values at that point of time, the target value to which was selected, and it's kind of giving me a particular cohort analysis, a nice graphs. So you can also share it with different stakeholder, and for both the model or both the dashboard, we can create this PDF file. Okay, with this, I'm going to stop now, and if there is any question, I'm happy to answer. Thank you.
Oh, thank you very much for that. That was great. So yeah, really enjoyed looking at that. I personally have used it a little bit when it was in public preview. So good to see it when it's out and it using its fullest ability. Have we got any questions? So we've got one from Alex. So How can organizations foster a culture of responsible AI throughout their teams and processes?
Okay. Sorry, can you just repeat the question once again?
Just how organizations foster a culture of responsible AI throughout their teams and processes.
Yeah, definitely. So there, as I was talking about all technical stuff, how can you build this RAI dashboard and everything through some Azure ML Studio? But the other aspect is very important to build that responsible AI culture within the organizations, and that must be driven by the senior management, and it should be the flow from in a top-down approach. I mean, that is my opinion, because if the entire culture of responsible AI, security, governance, accountability are not driven by the senior management, it's not going to hit the at the ground level. When we are working on certain project or certain model development, if we don't know these are the policies which should be applicable, data governance policy, data security policies, if these things are not driven by the top level management through some proper policy and governance guidelines, uh, there might be a mess or gap in this entire development cycle, or at end, once everything will be released and going to the production, everything will be halted, because on the other side, in the customer side also, they do have their own check. So we both should be in sync. I mean, from IT, as an IT company or service company, when we are building such solution, we must be aligned with our governance policy or our security policy, as well as with the client security policy. Because definitely, generally what we do, we generally adopt everything what is there within our organization policy, and we also need to adopt all the new things which are coming from the customer side.
Oh, thank you for that. We've got one more question. What are some of the common pitfalls to avoid when building a responsible AI model?
Yeah. So when we are building the responsible AI model, uh, the first step is the data. So sometimes what we do, let's say we are having millions of data, especially like we are working a lot of healthcare domain. So there we deal with whole lot of data, massive data. So a lot of time it happens that we sample data as per our requirement, as per our infrastructure, and as per our model development capability, because a lot of time it takes a lot of time. And as in the previous session we talked about, the infrastructure is very important when you are dealing with massive data. When we do the sample, we don't sample it with some intelligence. When we do the random sample, it has a different effect. But depending on the use case, if our sample is not touching all the different groups, especially which are sensitive groups, then it's quite possible, even if we apply the responsible AI framework and model, we'll be missing out some of the samples, some of the groups from the final model, because it's nowhere in this entire pipeline. The particular sample is not even injected in the pipeline. The particular groups is already dropped even before we actually source the data. Then it's dangerous. So nobody has seen that particular group in this entire pipeline, and decisions are being taken. But one fine day we might see that somebody has missed out because we have not even taken care of them. So that's quite dangerous, and a lot of time it's quite silent. It doesn't even alert. And so data sampling is very important, and we have to understand what is this model going to do, and who are the different groups will be impacted, positive, negative, both side we need to check. Otherwise we may miss out someone in this entire life cycle model.
Oh, thank you very much. Don't know if I've got time for one very quick one. With the dashboard, say if a stakeholder had hold of the responsible AI dashboard, is there any means of kicking off an action from using the dashboard? Say if they saw there was some sort of bias towards some sensitive feature, could they click a button to retrain the model to reduce the bias? Or is it one way, the dashboard?
Currently, so far I found it one way, but there must be some features. I'm sorry, probably I'm not able to tell you exactly it is possible with this Azure ML, but there are a lot of other mitigation techniques what we generally follow. There are some statistical mitigation technique, but yes, I need to explore that with RAI. I mean, in this particular dashboard, if we can just click the mitigation with one click solution.
Yeah. Yeah, fair enough. Okay, well, I think that's all we've got time for questions and things. So yeah, really enjoyed that talk. Thank you very much for coming along. And yeah, good to learn all about the responsible AI dashboard. So yeah, thank you. And please listen to the other talks.
Thank you.
Thanks. Right, so after a short break, we are going to be back with Leon, who's going to be talking all about machine learning in Power BI. So yes, please tune in about 5 minutes, and I will see you after the break. Hello and welcome back. So next I am going to be joined by Leon, who is going to be talking us through machine learning on Power BI. How are you doing?
Fantastic, thanks, Luke. How about yourself?
I'm very good, thank you. So
Excellent.
Leon is the director of ONNX Data, and he is, as I said, he's going to be going through an introduction to machine learning in Power BI. So yeah, thank you very much. And yeah, all over to you.
Fantastic. Thank you very much, Luke. Hopefully everybody can see my screen okay. So first and foremost, it's an absolute pleasure to be here with you at the Global AI Bootcamp, London 2023. As Luke mentioned, I'm going to be here giving you an introduction to machine learning in Power BI. I want this to be an interactive session, so please do feel free to, in the chat and the comments, let us know where you're joining us from, and also ask any questions that you may have throughout. As Luke mentioned, so my name is Leon Gordon. I'm a current Microsoft Data Platform MVP. Feel free to please connect with me on LinkedIn. You can do so by using the QR code. I'm currently a partner at a data analytics consultancy called Pomerol Partners, and I'm also the chair and founder of the Microsoft Power BI UK user group and also the Data DNA dataset visualization group. Outside of that, I contribute regularly as a writer for Forbes and also as a thought leader for the Brains magazine and the Global AI Hub. So, with that being said, let's go into today's session. And first of all, let's take a look at what we will cover today. So, first and foremost, we'll take a look at what is machine learning, often referred to as ML. Then we'll take a look at how we can benefit from machine learning within Power BI. We'll then look at how we can create a machine learning model in Power BI Premium or Premium per user, often referred to as PPU. And then we'll see how we can create a machine learning in Power BI for free. And I'll also give you some resources to continue learning. Now, a couple of caveats is we are limited in time for today's session, and I am going to go through quite a lot of detail, and I'm going to do so at pace. So we may gloss over some of the finer technicalities and leave those for more of an advanced session. This session will be very demo heavy, and I will give you resources to continue learning with after. Okay, so with that being said, first and foremost, what is machine learning? Well, machine learning is a branch of artificial intelligence, often referred to as AI, that teaches computers to do what comes naturally to humans and animals, which is to learn from experience. Machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. So what does this mean to us and what are we looking to achieve? Well, first and foremost, I want you to keep in mind that the key of what we're looking to achieve here is to enable the computer to learn from experience, and to do this by learning information directly from data. Okay. So how can we benefit from machine learning within Power BI? Well, as this is very much an introductory step, Power BI gives you some fantastic tools based on Azure AutoML that we can utilize out of the box for both premium and premium per user licenses. We can look at doing real-time predictions, customer churn analysis, customer leads and conversion, and also look at other elements like predicting fraud. Now, in today's example, I want to use a business use case, and we're actually going to look at how we can predict customer leads and conversion. Okay. So with that being the case, we actually have a theoretical organization which has quite a large problem, and the problem is twofold. So if we take a look at this diagram here, we can see that our fictional organization is spending quite a large amount of money on purchasing sales leads. It's actually spending £3 million. Okay. Now, as we go and scroll down to the bottom, we can see that their conversion rate is quite low at 4.3%. Now, in the image on the right-hand side, we can see that the lead's actually going through a sales funnel. So they're first receiving a sales call, then potentially a follow-up, then ultimately a conversion, which then finalizes in a sale. Now, wouldn't it be great if with this organization, they could A, spend less money on leads and identify those that are more likely to convert, which should then obviously increase their conversion rate as well. Now, we can do this using machine learning to start to take a look at and identify which leads typically convert for this type of organization, which will then enable them to either only purchase leads that they feel will convert, or ultimately spend less and purchase less leads they will just be converting. Okay. So with that being said, let's see how we can do this using machine learning in Power BI Premium or Premium per user. So with this being our first demo, let's go and make the machine learn. And although this robot doesn't look very happy, I can guarantee no machines were actually harmed in the making of this demo. So let's jump over to our GitHub environment. Okay. And first of all, let's take a look at two data sets. Now, these data sets are CSV files. One holds what we need in terms of some training data, and the other holds some customer data. Okay, so let's go over, open these files in a new window, and just take a look at the underlying data that's feeding into these. Right, so first and foremost, let's take a look at our sales training data. Now, this is historic customer data that we're actually going to use to train our machine learning model. So some of the attributes that we have here are, for example, the age of a lead, their marital status, their gender, their yearly income, the total amount of children they have, the number of children at home, their education, their occupation, whether or not they're a homeowner using a Boolean flag, the number of cars owned, their state province code, their postal code, and finally we have a flag denoting whether or not they became a buyer with our organization. Okay. Now let's take a look at our lead data. So this is our prospective buyer CSV. Now you'll notice this data comes from a transactional system, as we have a buyer key and an alternate key. And then we have our first name and last name for the leads. And then ultimately we have common attributes across the data sets. So they are age, marital status, gender, so on and so forth. But what you'll notice, as this is lead data that we haven't actively sold to before, we do not have a buyer flag at the end of this. So what we're going to do is look at how we can create a machine learning model that will predict whether these leads will actually become buyers with us or not. So to do this, let's jump over to the Power BI service. Okay, just while we do that, I'm going to open up the raw versions of these files to save a little bit of time as we progress. Okay. So let's go ahead and ensure that first of all, we are in a premium or premium per user workspace. So I have one here called Sandbox. And to get started, what we want to do is go ahead and select new, and then we want to create a new data flow. Now, those of you that are aware and use the Power BI service will know that data marts, which are in preview, have recently entered the Power BI service. So Microsoft is going to prompt us if we would like to use one. For the purposes of this demo, we're going to say no, and we want to continue working with a data flow. Now, we'll be linked to quite a nice UI that's going to guide us through how we can either define tables, link tables to other data flows, import models, or attach a common data CDM folder. So in this example, we actually want to add a new table. And again, those of you that are familiar with Power Query Online will recognize this screen. So for this, we want to actually use Power Query Online to choose our data source connector. Now, for the purposes of today, we want to use a text CSV connector. Okay, and it's going to ask us for a file path or URL. Now, I recommend that we use the raw URL for each of our CSV files. Okay. And we can go ahead and paste that directly into our connection settings and select Next. Okay. Now, in the background, Power Query will parse the data being presented to it, and it will actually give us back a preview of the underlying data set. Whilst that's just loading, I'll also go ahead and grab our sales training URL. And this is always the joys of the demo gods when presenting, that we may have a little bit of slowdown. Okay. So now with that being said, we can see that Power Query has parsed the data being provided to us. It's successfully identified that the first row is actually headers, and it's started to denote some of the data types it's receiving as well. As you can see, some of these have already been attributed. So for the purposes of today's demo, let's go ahead and say that this is correct. We don't need to make any transformations, and we can go ahead and save and close our first table. Now, we can give our data flow a name. So let's call this ML, let's go for Global AI London. Let's give it acronym version. And I would always recommend that whenever you're developing, you always leave a description, which is very informative to any other developers that may be working in this environment, and also to your future self. Now, as I don't have any other developers working with me today, but I do have a future self, I will leave a very brief description. Okay, this is a description. Let's go ahead and select save. Now, what will happen next is Power BI in a service will prompt us to see if we want to either refresh or set a refresh schedule. And for the purposes of today, we don't want to do either. So excellent. We now have our prospective buyer. So this is our lead data within our data flow. And now we want to go ahead and add a table. Okay. And we're going to follow the same process. So we're going to select our data source as text CSV. We're going to paste. It hasn't saved on the page, so let's go ahead and copy that again. Our training data, we're going to copy our URL here, paste it directly into our connection settings, go ahead and select next. And once again, Power Query Online will just pass the data set being provided to it. And once again, you can see that it's started to call out the correct data types and also use the first row as headers. So we don't need to make any further transformations. And we can go ahead and save those. Okay. Fantastic. Once again, just for good measure, yes, there it is. We will be asked if we want to refresh, which we don't want to do at the moment. So fantastic. We now have our training data and our lead data within our data flow, and we want to now start to build out our machine learning model. And we can do so by selecting machine learning models at the top here. Now, once again, we're greeted with a very nice UI as a wizard that's going to walk us through exactly what we're going to be doing. So first and foremost, we'll be creating and training our model, and we'll be doing this by selecting our training data, choosing a model type, and ultimately training our model. We'll then look at ways that we can improve our model. So this is by iterating and retraining before ultimately applying our model predictions to our lead data. So let's go ahead and get started. Excellent. So first and foremost, we'll be asked what we would like to predict. So in this example, we know that we want to predict whether our training data information will become a buyer. Okay. Let's go ahead and select next. Now, once again, in the background, the AutoML in behind the Power BI service is passing the data within the data flow being presented to it, and it's actually recommending a prediction model to us here. So you'll notice that it's recommending a binary prediction, which is to predict whether or not an outcome will be achieved. And this is actually the correct model for what we're looking to achieve today. Now, if it wasn't, we could go ahead and select a different model. And we have different models to choose from based on classification or regression. So as we noted, we had our binary prediction model, which was correctly recommended. And this allows us to determine the likelihood of a sales lead converting or the probability of a customer responding to a marketing campaign. So this is indeed correct. But we also have general classification, which allows us to distinguish between 3 or more outcomes. So this is generally used for classifying credit card applicants into groups of those who have good credit, bad credit, or those that require further analysis. And my favorite, regression, which estimates a numeric value. Now, this can be used for estimating house prices in a market based on regional factors. So as I mentioned, the binary prediction model is correct. So let's reselect that. And we want to choose our target outcome. Now, as we know, our target outcome is whether an individual was a buyer with us, which means the value needs to represent a 1 denoting true. Okay, I'll just change these labels so that if we get a correct match, we will label it as a buyer. And if we get a mismatch, we'll label it as not a buyer. And it looks like our screen is a bit small, so let me just zoom there so we can see the buttons, and let's go ahead and select next. Now, once again, in the background, the Power BI is passing the data being presented to it, and it's actually looking for any correlation within the columns of data that we presented to it. Now, in the machine learning world, these columns are actually referred to as features. So from this moment forward, I'll start to refer to them as features. Now, within this data set, we're being recommended the age, yearly income, the total amount of children, the house owner flag, and the postal code has a high correlation with the outcome of an individual being a buyer. And that's Power BI's recommendation to us. Now, me being myself, I would like to invoke a little bit of chaos, so I'm going to do so by selecting those that Power BI is not recommending, and you'll see why shortly. So let's go ahead and select next. And then we can actually name and train our model. So let's call this ML Global AI London. As I mentioned, please do leave a description. The better the description and the more informative it is for your colleagues and your future self. Now, generally, whenever I practice or train on something, I like to think that the longer that I do it, the better I become, which is generally the case for machine learning models as well. So we're able to set a training time here from anything from 1 minute up to 360 minutes. Now, for the purposes of this, I'm just going to set this all the way down to 5. And then we can see what will happen next. In the background, a statistically significant sample of data will be taken to train the model. So it will take 80% of the underlying data we provide it to base its training on, to iterate round and base its predictions on. It will then use the remaining 20% of data to then test those predictions against. Okay, so we can go ahead and select Save and Train. Okay. Now, in the background, our model will start to refresh, as you can see here, very similar to how a data flow or a data set would generally refresh, and that is now training our model in the background. At this moment, Luke, I'll just briefly pause for any questions.
No questions at the moment, but
fantastic.
Yeah, feel free to keep going.
Thank you very much. Okay, so let's hop over to a previously deployed version of our machine learning model, so we can pick up where we would be once we've finalized our machine learning model training. Okay, so we'll be presented with a training report, and we can go ahead and view this training report. Now, what this gives us is a summary of our model performance, any training details, and enables us to start to optimize our machine learning model in a bit more detail behind the scenes. Okay. Right, I'm just going to jump back to the excuse me. I'm just going to jump back to the first page of our report. Excellent. Now, this will give us a bit of information in terms of how our model was evaluated and the model performance, which is often referred to as the area under the curve, or the AUC. Now, again, I'm going to gloss over a lot of technicalities within this session in an effort to stay on time, but generally excuse me, generally an AUC between 70% and 100% means a good model performance. So let's take a look at our top predictors, okay, which we can do so by clicking here. Now, as you would have noticed earlier, some of the features that were given to us as a high correlation by Power BI were age, marital status, total children, and postal code. And I invoked a little bit of chaos by including other features which weren't attributed to have a high correlation. And you can see why now in this report. So Power BI was actually recommending us correctly that these features don't have a high correlation with our output. Now, as we start to click through some of these features, we can start to identify the patterns in terms of individuals that buy with our organization. So, for example, their age is generally 46 years and less, or 46 to 59, so generally 59 and lower. Their marital status is generally single, and the number of children that they have is generally 1 at home. Okay. Now, if we just close this, I'm going to give you a very brief overview of this matrix here. It's called a confusion matrix. And the best way to read that is by looking at an image similar to this. So in the top left-hand cell, we have a true positive. So this is where our machine learning model predicts that the true outcome is positive. And similarly, in the bottom right-hand, we have a true negative. So this is where our machine learning model correctly predicts that the value is going to be a 0. Ultimately, outside of that, we have both a false negative and a false positive. Now, the values we're most interested in today is the uppermost left and the bottommost right. Okay. Now, with that, we're able to see here that for an actual buyer, we actually have a fairly good amount of true predictions in that cell. And we can use, in this example, either recall or precision by increasing or decreasing here to affect these numbers. So if I just go ahead and increase precision, you'll notice the effect that it has on the confusion matrix. Now, generally 0.5 is a good starting point. So for the purposes of today, I'm going to set it to 0.5. Okay. Now, with that being said, let's have a brief look at our accuracy report. Okay. Now, again, going to gloss over a fair amount of the detail here, but in this visualization here, we can start to see what is the ideal. So this is an ideal prediction, which is the teal line, which is now highlighted. We have what would be a random guess. So this is a prediction that is just randomly predicted in this line. And we have how the model performed. Okay, so in this example, it's performed relatively well in between an ideal and a random guess. Now, jumping onto our training details. Okay, this gives us some insight into what happened behind the scenes when our data flow refreshed and our machine learning model was actually trained. So we can see the amount of sample rows that we used. We can see how many of those rows were actually used as training rows. We can see the final model used. So in this example, it's a pre-fitted soft voting classifier. And we can see how many iterations were run. So within that 5-minute period, 32 iterations were run on the data. And we can start to see the model quality over those iterations on this trend line graph here. Okay. Again, we go into a little bit of information in terms of the features, their data types, and the parameters we selected in terms of the min models, the maximum models, and the seed threshold. Now, once we're happy and we don't want to apply any edits, we can go ahead and apply our machine learning model. So what this means is we're going to actually apply our predictions to our lead data. And we can do so by selecting our prospective buyer tables. This is our lead data. We can give a new name to the prediction column, which we can call outcome. And as we said, we've gone with a 0.5 threshold for this. Now, if you are following along at home, then you can go ahead and select save and apply. But as this is already a pre-deployed version, I'm going to go ahead and select cancel. Okay. Now, once you're happy and you've applied your model to your lead table, you'll notice that we started with 2 tables within our tables environment. We now have an additional 4. Okay. The first one is the training data. So this is that 80% of the data set that was used to train the predictions on. We then have that 20% of the remaining data, which is the testing data. And most importantly, we now have our prospective buyer data, which has now been enriched with our buyer predictions. Okay, so this is those predictions from our machine learning model. And then we have a metadata table which holds in it all of the explanations in terms of why our machine learning model based the predictions that it did. Now, in terms of our time in the Power BI service, this is now complete. We have created our machine learning model, trained our machine learning model, and ultimately applied it to our lead data. Now, how can this become beneficial to us from a reporting perspective and to our sales teams? So let's go ahead and go into Power BI. We're going to create a new Power BI or PBX file, and we're going to make a connection to our sandbox workspace and then head over to our data flow. Okay. So we'll be opening Power BI desktop and be greeted with the familiar Get Data screen. So let's go ahead and get our data. Okay, has Power BI opened this on a different screen? Yes, it has. Here we go. So now we're going to our Get Data wizard. Let's go ahead and select Data Flow. Okay, now we want to use the data flows. Go ahead and connect. As I mentioned, this will establish a connection to our workspace for the user that we're signed in with. Okay, so let's go ahead and go to our workspaces. We want to select our sandbox workspace, which is our premium per user, and we want to go to the previously deployed version of our data flow. Okay, now as I mentioned, we want that enriched bioprediction data set. I'll just go to transform data rather than wait for the preview to load. Okay. And this will present to us our Power Query editor now, but in the desktop version. And what we'll notice once this loads within our data set is we're looking at our lead data. So you'll notice by the fact we had our bio key, our alternative key, first name and last name. If I just scroll to the right, you'll notice now that we have some additional columns available to us, and they have the prefix bioprediction. Okay, so first and foremost, we have the most important column, which is our outcome column. So this is the predictions from our machine learning model that has been applied to our lead data. We then have a prediction score. Okay, now this is the weighting in terms of how accurate the prediction is, with a larger number being more accurate. We then have our prediction explanation and our explanation index. Again, this is just some insight in terms of why our machine learning model predicted what it did. So let's go ahead and close and apply that. This is a fairly small data set, so it shouldn't take too long to load. And then I will go through very briefly some rudimentary visualizations in terms of how we can use this data for our organization. Please bear in mind this is not going to be a data visualization session, so the visuals are going to be very rudimentary. So we now have our table available to us. Okay, so let's take a look at getting our lead's first name, their last name. Let's also get their bioprediction outcome. So this is that machine learning model prediction. And let's also get the scoring against that. Now, be careful with the scoring because Power BI does auto aggregate this value. So we want to go to don't summarize. Okay. Now let's just make this table slightly bigger so we can all see it. And let's apply a rudimentary slicer based on the outcome. Okay, so now we can see that we have our lead data, which has a prediction applied to it, and a prediction scoring applied to that as well. So for our sales teams, if we just wanted to use the leads that were more likely to convert based on our machine learning model predictions, we can go ahead and select true. We can then sort our prediction score descending and work our way through this list based on who we believe would have a high likelihood of converting for us from a sales perspective. Alternatively, we can do the same for those leads that we feel won't have a high likelihood of converting for us by flipping over our slicer to false. So you'll see how quite quickly there we can get up and running using machine learning within Power BI to actually solve business issues that can bring us value and hopefully more revenue in the future, which is absolutely fantastic. But just returning to my slide deck, as you all know, not everybody has access to Power BI Premium or Premium per user. So wouldn't it be great if we could do this for free? And we can, but I need to caution you that there are some limitations to this approach. So there are no machine learning ops in this session with this approach, and you can only use the personal gateway. It becomes very difficult to manage dependencies, and it is by no means scalable. So I want to give you an art of everything that's possible from a Power BI perspective. But to be honest, by the time you're getting to this point, you should be moving on to the likes of Azure AutoML, Databricks, etc., and really escaping the limitations of Power BI at this point. But I will show you this anyway. So with this being said, we do need to use some alternative tools. So the first of those is Anaconda. Now, Anaconda for me is by far the easiest way to get up and running with Python or R data science environments within your machine. And we're also going to use the PyCaret library by a gentleman called Moez Ali. PyCaret is an open source, low code machine learning library in Python that enables us to get from prepping data to models very quickly. Now, the QR code being displayed here will give you access to the GitHub repo that I've been using through today's session, which also has the slide deck as well for further reference. So please do feel free to capture that QR code or revert to it in a recording of this session. Okay, so for those of you that do need to to get Anaconda, you can do so by going over to anaconda.com, going over to products, and you can get the Anaconda distribution, which is freely available for personal use. Once you install this on your system, you may also need to have to install some Microsoft C++ build tools, which again, you can do so by just by searching Microsoft C++ build tools. Okay. Now, once you have Anaconda installed on your system, you can then go ahead and use what's called the Anaconda prompt. Okay. So I'm just going to open this. And we're very simply going to enter 3 lines of code to enable us to start using Python and PyCaret within Power BI. So first and foremost, I'm going to use the activate command to activate a environment that's called data science _UG. And you can think of this environment as like a container. So you'll notice we've now gone from our base environment to our data science _UG environment. Now, this has a clean install of Python on it, and we need to go ahead and install some dependencies as well. So to do this, we can use the conda command to install pip. Now, pip is already on this system, but pip is just a package and library manager for Python that we need to install before we start to install any other packages or libraries. Okay. This may take longer on your system as you may be doing a fresh install, whereas as I mentioned, this is already installed on this system. So once we have pip installed, we can use the pip command to install PyCaret. Okay. Now, once again, PyCaret is already installed on this system, so all of the requirements are satisfied. This may take longer when you're doing it in your environment. Okay, so excellent. We now have our Python environment all ready to go. We need to now make Power BI desktop aware of this environment. So to do so, we can go into our file, our options and settings. We can then go to options. I'm hoping, there we go. Okay, so options, and then we can go to Python scripting in our global section. Okay, now what you want to do is you want to go ahead and select your home directory to other, and then you want to navigate to your new Anaconda environment. Okay, so as you'll see, we have our environment, which is data science _UG. Okay, which mimics exactly what we had in our Anaconda command prompt. Then you can go ahead and select OK, which will apply those settings, and you now have Python scripting available to you in your environment. Okay, so fantastic. Now, I'm just going to show you, we've only got 10 minutes or so left, so I'm going to really gloss over a lot of the technicality to this. But one difference to bear in mind is that when you're actually getting the data from our CSV files in our GitHub environment, you need to use the web connector as opposed to the CSV connector. Okay, the text to CSV, we're going to use the web connector. So let's go to our pre-existing queries. Okay, and for example, let's just go back to the source for our lead information. And you'll notice, like I say, we're using our web connector, entering our URL from that perspective. Now, what we're going to do is, in our GitHub, you have access to 4 scripts, okay? You have 1, 2, 3, and 4. So I'm just going to open these up in separate windows so we can get rid of our data ones now. Let's go ahead and open these scripts up. Now, in behind these scripts that I previously created, we're going to go through the same process that we did on the Power BI service, but unfortunately not with a nice wizard UI. We're going to do it using code. So you can feel free to copy these scripts. All you have to do is copy these out and paste them into the Python IDE within Power BI. So with that being said, let's just go back over to our demo, and I'll walk you through what each of these steps does. So ultimately, we're starting off with our training data. Okay, we've imported our source, which is our web connector. Now you'll notice the difference here is that Power BI isn't able to establish, or Power Query in a desktop isn't able to establish that our first row is headers or our data types. So we've gone through the steps of applying and promoting our first row to headers and changing our data types also. Now, what we can now do by going to transform is run a Python script by selecting run the Python script from within the scripts section. Now, what that will do is launch a very rudimentary IDE within Power BI, whereby you can just paste in the first script. Okay, so our first script from here, you can paste that in against our sales training data. Now, it's worthwhile noting, those of you that are familiar with Python, any data frame that you create will become available for you at the end of that applied step. The one that we're interested in is df_imputed in this table, and we can just go ahead and expand that. Now, what this first step will do, it actually encodes or imputes the underlying features to give each of them a unique value which is required to use the PyCaret library. So the easiest way to see this is with gender. So you may remember we had in this data set male and female as the genders. We now have two distinct values, with male and female being encoded to 1.0 and to 0.0. This is similar for all features within this data set. Now that we have this in the right shape for us to be able to run our PyCaret library, we want to go ahead and select Run Python Script again. Okay. This will once again present to you our rudimentary IDE within Power BI, and you can go ahead and select My Second Script. Okay. Now within this second script, what we're doing is recreating the training of our machine learning model, similarly to how we did within the Power BI service. Okay. Now, as I mentioned, you will be presented with every data frame by doing it this way, and the one that we're interested in is the predictions data frame. So we can go ahead and select table and expand that. Now, what will happen is that, again, we'll have some additional columns on our training data. So this is our label and the scoring. And they will be saved into an external, what's known as a pickle object. But again, we don't want to get too technical in this session. Okay. Now we need to apply this to our lead data. So to do so, once again, we import our data, we promote the headers, so the first row, and then we are in a position to run our first Python script by selecting Run Python Script. Now, within this script, we want to use the third script from within our GitHub environment. We can copy this out. Okay. Paste it directly into our IDE. Once again, we can go into our df_imputed table and expand that. And we're presented with our lead data, whereby we've encoded those values so that we can actually use the PyCaret library. We then want to again select Run Python Script, which will present us with our Python script. And this is the smallest, but by all means the most one of the most powerful, is we're now going to apply our machine learning model predictions to our lead data using this script. Okay. So let's go ahead and we can select OK. Once again, we'll be presented with the data frames, and the one we're interested in is predictions. Okay. Now you'll know and our score applied to this data. Now, I do have some other transformations that take place just to tidy up this data set. So you'll notice that, for example, our first name and last name are still encoded. So I merged those back just so we can present this once again. So let's just close this. And you'll notice that we're now able, let's just jump back. So let's go to our lead data set. Let's take our first name, our last name, our label, which is our outcome, and our score. And what you'll see is that using PyCaret and Python within Power BI, we're now able to replicate the same functionality that we had previously within Power BI and Power BI Premium per user. So let's go ahead and select those individuals that our machine learning model predicts will become a buyer, set our score to descending. Okay, and we now have a list of individual leads that our machine learning model predicts will become a buyer for us. And ultimately, we can do the alternative of this, which is set it to false for those that our machine learning model predicts will not become a buyer for us. Now, again, this can be super powerful. As I mentioned, there are a lot of caveats to this approach, so please do bear this in mind. But this is to give you an understanding of the art of the possible. Like I say, at this point, really, I would be looking to do this outside of Power BI. Just for completeness, I've shown you this version whereby we've gone through step by step, so you can understand what's happening to the data behind the scenes. But my recommendation would be to use an individual Python script that does all of these transformations as opposed to the applied steps. Now, to do this, what you want to do is use a new data source, which you can go to More. You can select, let's open up in a new window. So we'll just bear with it a moment. Okay, we can search for the Python data source. We can use Python script. Okay, I'm just going to cancel that. Now, once you do use the Python script, you'll be presented once again with that rudimentary IDE. You can paste your script in here. Now, I do have in our GitHub environment this script available for you, which is Python end-to-end ML. Okay. Now, what you'll notice with this script is it does every single import, the training, the applying of the predictions and dropping of the data frames in a single script, and it's a lot more efficient than doing it in the individual Power Query steps. So once you've run that script, you can just open the final predictions table, and you'll be presented with your leads with the actual scores and labels against them. And just for completeness, I will pull that information into Power BI Desktop, and then I'll go through and give you some alternative resources and be in a position to answer any questions that you may have. Okay, so let's just get rid of these visuals. Let's go and use our Python leads dataset, select our first name, our last name, our label, which is our outcome, that's scoring again. Let's put in our rudimentary slicer based on that label. Let's go for true, let's sort that by the score descending. And there you have it in terms of using an individual Python script to be able to run through that same process. Okay, and that would be my recommendation from that perspective. Okay, so that's how we can use Python for free using PyCarrot and Anaconda within Power BI to achieve the same outcome as such. So with that being said, we now have a vision. And excuse the Marvel reference, I'm a big Marvel fan. But here's how we can take it to a new level. So we can also do things like outlier detection using PyCarrot, potentially topic distribution, association rule mining, and other advanced analytics using this approach. Now, as I mentioned, I will give you some resources to continue learning. One of my favorite books on the subject is by fellow MVP Luca Zavarella, which is extending Power BI using Python and R. Absolutely fantastic read, so I do encourage you to go and get that. Also, for those of you that follow data science, I would recommend you use kdnuggets.com and Towards Data Science. And as I mentioned, the Anaconda distribution is available on anaconda.com, and Microsoft also has some fantastic resources to continue your learning on this subject. So with that being said, I would like to thank you all for your time today and for joining us at the Global AI Hub London 2023, and take the time to take any questions.
Oh, thank you, Leon. That was really good. I do have to admit, every time I see these low-code, no-code solutions, I'm a bit dismissive at first, but frustratingly, they're always pretty good, which is worrying because it might put me out of a job one day. But yeah, that was really good. I liked it. Got a few questions. I have to apologize. I did say there wasn't any in the break, but one popped up just as I said it. That was a great talk so far. Is there are there any ways to know which model is being used under the hood?
Not particularly. So I'm guessing you're asking from an AutoML perspective, and what's really, so we know which classifiers being used in the background, but it's a bit of a black box, to be honest, from a Microsoft perspective. So the full answer to that is no, not really.
Cool. Thank you. They also have another question. Is it possible to change the size of the test set or use something like cross-validation while training?
Not using this approach in Power BI, using the Python approach, then yes, that is available. And I also believe, happy to be created on this, but you can also do this using Azure ML. But as this, again, just to kind of reiterate, I don't see, so in Power BI you are limited. It's really good breeding ground to be introduced to machine learning, to be able to productionize machine learning models in a safe environment. But I think you will run into a lot of restrictions very quickly as you start to get more familiar and up to speed with machine learning and building out models. At that point, the approach does become something like Azure ML, or something which is based on code. If you're familiar with code, going down the route of Python or R, and again using things like Databricks and Azure pipelines, etc.
Thank you. So this is a bit of a long one, but I'll put the second bit up. So it says, I have premium per user, but not premium capacity. When trying to create an ML model, I receive the message, machine learning model requires premium. This workspace needs to be assigned to a premium capacity. And then the question is it actually a must-have premium capacity and not just premium per user? Thank you.
So without being in this user's environment, I'll take a stab at this. So the test and the demo that I displayed to you today is using a premium per user license. Now, on the face of things, it sounds like your first point of call to try is to see if you're trying to do this on a premium per user workspace. It could be the case that you're just using a pro workspace whereby you may be getting this error. Outside of that, like I say, if you are using a premium per user workspace to create this data flow, you shouldn't have any issues in terms of being able to use this functionality. If that is still the case, then I suggest reaching out to a representative at Microsoft or the Microsoft community. But please do first check that you're using a premium per user workspace.
Oh, thank you. I've actually got a quick question. So how do you think this would compare to other sort of tools that offer low code, no code solutions, such as like Data IQ or Data Robot? Do you think it can compete?
I think the problem with tools, and this becomes the same with Power BI, Tableau, Click, etc., is there's a lot of crossover in terms of functionality with each tool. You have to think about your department's skill set. You have to think about your end users and their familiarity. So I think this is very much a case by case discussion to have in terms of what the end goal is. Now, in an effort to try and answer that question, by all means, using ML in this way in Power BI can compete. And to be honest, it's pretty robust when in capable hands by using this walkthrough. Now, does it scale? I would debate that, but then at that point you should be moving on to other tools within the Microsoft stack, like I mentioned, Azure AutoML, Azure Databricks, etc. From that perspective.
Yeah, that makes sense. Oh, thank you for that. I think that's all the questions. So yeah, really appreciate delving into Power BI and machine learning. So yeah, we got one more talk after this. So feel free to follow our next talk, and thank you very much for coming along, Leon.
Excellent. Thank you very much for having me. Take care, everyone.
Cheers. Take care. Right. So we have a short break, and then after this, we have the last talk of the day, and that is going to be on enterprise-grade help desk bots using conversational AI. So yes, do come back for the last one, and I will see you all in a bit. Hello, everyone, and welcome back to the final talk of the day. And I would like to introduce you to Prashant. So he's a cloud solution architect at Applied Information Science, and he's going to be talking to you about business intelligent enterprise grade help desk bots using conversational AI. How you doing?
Hey, look, I'm doing great. How are you doing today?
Yes, I'm very good, thank you. Looking forward to listening all about this. So yeah, if you're ready, it's all over to you.
All right. Thanks, Luke, and thanks everyone for joining us today. Good evening, good afternoon, good morning, depending on your time zone. So the title of this talk is Building Intelligent Enterprise-Grade Helpdesk Bots Using Conversational AI. Who am I? My name is Prashant G. Bhoyar. I was born and raised in India. I came to United States in 2007 for studies. I'm University of Maryland College Park alumni. I co-authored a book, PowerShell for Office 65. I also acted as a technical reviewer for the book Pro SharePoint 2013 Administration. I am from Washington D.C. area of United States, and we have very active community here. Before COVID pandemic, we used to have a lot of community in-person conferences, but ever since the pandemic has started, for first couple of years we had 100% virtual conferences, and now we are starting to get hybrid conferences where you can join in person as well as remotely as well. So if you're interested joining us, definitely check us out on azurecloudevents.com. I am recipient of Antarctic Service Medal. I got this award from US government for the work I did in the Antarctic continent back in 2008. And since 2017, I am recipient of Microsoft MVP award. Those of you who are not familiar with this award, I don't work for Microsoft. It's just additional recognition that Microsoft gives out to the folks who does technical contributions. And these technical contributions can be in the form of speaking at conferences, writing blog posts, contributing to the open source project, answering people's questions on various public forum, or providing direct feedback to the Microsoft product group. And typically, this award is valid for 12 months or 1 year only. And after uh, 12 months or 1 year, you have to submit your contributions. And if your contributions are good enough, then Microsoft will give you this award for additional 1 year. As far as my day-to-day job is concerned, I work as cloud solution architect at Applied Information Sciences, where I focus on intelligent business process automation. I know it's kind of sound mouthful, but what I essentially do is I help customers to implement automation. And while doing that, we use a lot of services in Microsoft ecosystem, such as Azure, Azure AI, Conversational AI, Microsoft Power Platform, Microsoft 65, Teams, SharePoint, etc. And I work at AIS Reston Virginia office, and AIS has been providing services in Microsoft ecosystem from last 40 years. And we have been recipient of Microsoft Partner of the Year award on multiple occasions. AIS is growing. So if you know anyone who's looking for a change, we have a lot of open positions, and candidate can be 100% remote as long as that candidate resides in either US, Canada, or in UK. So let's talk about today's talk. So we will start with why we have to invest time in terms of learning about chatbots and virtual agent. Now it's kind of easier sell than before because of all the hype around ChatGPT. Then if you are serious about implementing chatbot or virtual agents or voice-based bot in Microsoft ecosystem, what are some of the options we have, how we can get started, what are cognitive services, what are Microsoft Azure OpenAI service. I will have demos, key takeaway, and Q&A. So feel free to post your questions in the comment section. I will be monitoring that, and we also have Luke who will be helping that as well. So I always have this slide whenever I do any kind of technical talk. Technology or tool doesn't matter. Problem solving matters a lot. So this is the mission statement from Microsoft. They would like to make data science and AI accessible to everyone. And it doesn't matter what your role is, where you're located, and what kind of device you're using. Some of the services that are coming from Microsoft quite aligns really well with this mission statement. If you look at AI services in Microsoft stack, the core AI services are part of Azure AI. where under scenario-based services, we have bot service, we have cognitive search, form recognizer, video analyzer, metrics advisor, immersive reader. Under customizable AI models, we have vision, speech, language, decision, and OpenAI. And if you would like to build your own machine learning model and host those models in Azure, then Azure Machine Learning is for you. Azure AI is a first party service. What does that mean? That means not only we as a customer can use it, but inside Microsoft, other product groups also use the same services that we have access to. For example, if you are familiar with Microsoft 65, then there is a service called Microsoft Syntax. Behind the scene, it uses the same Azure AI service that we have access to. One of the service that you're seeing right now that I'm using is real-time speech to text. This service is directly built with Microsoft Power Platform, and behind the scene, Microsoft PowerPoint, and behind the scene, PowerPoint is actually using speech to text a service. If you are familiar with Power Platform, within Power Platform, we have Power Virtual Agent, and behind the scene, they also use the same Azure AI services that we have access to. So now let's talk about why we need to invest time talking about bots or virtual agent. So bots gives us more natural human or computer interaction. And also they help us to automate repetitive tasks and free up other resources. Virtual agents or bots can be available all the time. They can be available depending on where you are, whether you are driving your car or whether you're walking on with your phone or whether you are in front of your desktop. And also, if your implementation is right, the bots can adapt to the user depending on the circumstances. However, the number one reason that we see where virtual agents or bots getting extremely popular, especially in the enterprise space, is because of this number two reason. And if you remember March 2020, when COVID-19 pandemic started, majority of the organizations throughout the world started asking their employees to work from remotely. uh, Few companies were ready for remote work, but majority of the organizations were not. And guess what? The number one department who suffered a lot during that time was the IT help desk. And that's where a lot of companies started investing or started exploring, can we use chatbots or virtual agents as an additional arm for our existing help desk? And during the same time, we saw a really huge uptick in the conversational AI space. A lot of startup started doing really creative stuff over there. Even big organizations like Microsoft, Google, OpenAI, Amazon, they started investing heavily in that space. Also, virtual agents are bot kind of give you easy, natural, easy to follow user experience. And if its implementation is done right, it simplifies UI and it supports multiple channels, and it also may help you to connect with younger users as well. So we, as end user, is already familiar with chatbots or voice-based bots in our personal life. If you are a customer of a major financial institution such as HSBC Bank or Citigroup or Bank of America, and if you dial their customer service number, chances are their first defense is going to be a voice-based bot. That bot will ask you some questions, and depending on your answer, it may show you some additional information, or it may connect your call to an actual human agent. Now, same thing like a lot of enterprises would like to do for their internal users as well. And if you are a Microsoft shop and you would like to use some of the technologies in Microsoft ecosystem, then we have these two options. Again, similar services are available, let's say something from Google, from AWS, and IBM, and other major players. And also there are a lot of startups as well where they have their own intelligent chatbots or virtual agents or voice-based bot. Inside Microsoft ecosystem, we have two options to create chatbots. We can use platform as a service where we have Microsoft Bot Framework. Microsoft Bot Framework is an open source SDK and tools, and its purpose is to build custom bots. Right now, 4 major languages are supported. You can either use C#, Node.js, Java, or Python to write your custom bots. However, if you would like to host your bots using Azure Bot Service, then only Node.js and C# is supported. What does that mean? If you create your custom bots using Java or Python, you need to post that bot somewhere else and use Azure Bot Service for that. And the software as service, we have Power Agent. It provides you a no-code experience for bot development. Any news Power and it uses bot uses Azure AI services that we just talk about. However, new of virtual agent or chat doesn't have to be another tool. It's also tool Microsoft Bot Composer. It helps you to build complicated chatbots that is possible with Power Virtual Agent. However, when you design that is available with Power Virtual Agent, a lot of that is with Composer actually came to the Power Virtual Agent. However, new available, and hoping uh, generally available in next few. And have a few teams and say have team experts, and each team their own tech. For example, professional use bot frame and the developers use virtual agent. Then you guys can deploy your custom.
Hello, I do apologise. We seem to have had a connection issue from Prashant, but as soon as he's back, we shall continue with the talk. Hello, I do apologise. There must be a connection issue. However, if you want to go over to the Johnny 5 channel, there is also a really good talk going on at the moment to do with explaining oracles, techniques to communicate machine learning model results. And yeah, if you're really keen, then please stay on this channel. He's probably going to come back, but if not, feel free to go over to the other channel. I can only apologise, but technical issues. Anyway, thank you. looks like Prashant is back, so we're back on with the talk and let him continue.
Yeah, thank you, Luke. And first of all, I'm extremely sorry for some of the network connectivity issues at my end. Thanks for your patience and sticking with this live broadcast. So before I had internet issues, we're talking about Power Virtual Agents. So Power Virtual Agents is one of the members of Microsoft Power Platform, and we use Power Virtual Agents to create intelligent chatbots. Microsoft Power Platform, anyone can use Microsoft Power Platform. You can be a professional developer, you can be a citizen developer, or you can be a domain expert who doesn't want to write any single line of code. And the data service that we have with Power Platform is Dataverse. And it also has AI capabilities in the form of AI Builder. And the PowerFX is a low-code programming language we can use with Power Platform. So Power Virtual Agent sits on the top of Pyramid. It is built on the top of Azure Bot Service, and it also built on the top of Azure Cognitive Services. It has a very tighter integration with other Power Platform products such as Power Apps, Power Virtual Agents, and Power BI. And we can easily communicate to the outside world using direct integration with Power Automate. And those of you who are not familiar with Power Automate works on the same principle as Azure Logic Apps, where you have connectors, and those connectors can be from services within Microsoft ecosystem or from non-Microsoft ecosystem. And you can also use custom connectors as well. And that is going to be your gateway to the outside world. And this is the typical life cycle you will be following when you create any kind of virtual agent, chatbot, or voice-based bot using a Power Virtual Agent. It has a really nice, robust designer that anyone can use to create a sophisticated virtual agents. And if you have any inbuilt knowledge base, just like we can do that using the language service in Azure Cognitive Services, we can do that with Power Virtual Agent as well, where you can create some predefined topics using your existing knowledge base. These are some of the key concepts that you need to understand before you start using Power Virtual Agent. Topics is going to represent your conversational flow road map based on the different needs. For example, you can have topics for your employee benefits. You can have topics for PTOs. You can have topics for IT help desk. You can have topics for, let's say, requesting a training. Then you have entities, and we can use entities to translate data supplied in a text and extract some meaningful information from it. Now, one of the key principles that you have to keep in mind when it comes to virtual agents or chatbots is we are trying to mimic human conversation as much as possible. And what happens is typically when we communicate as a human with each other, we can share the same information in multiple ways. For example, if I'm talking with my friend, and if my friend asks me like, hey, when are you going on vacation? I can respond to that question in multiple ways. I can just explicitly give him the date, or I can say, hey, I'm going next Wednesday, or I'm going first Wednesday of next month. And we as a human can comprehend that information. So idea is using entities, our virtual agent should also be able to comprehend that information. Then you have nodes that can help you to connect your business logic. Then you have variables. The concept are similar with any other programming language or low-code, no-code tool. Then you can use synonyms and you can use triggers. So triggers are optional for topics, but they are highly recommended. And triggers are the one which can help you to trigger a specific to start in specific a topic. There are some predefined entities are there, and you can also build your custom entities as well. And one of the key advantage of using tools from Microsoft is whether you go with Microsoft Bot Framework or you go with Power Virtual Agent, you have to build your chatbot or virtual agent once, and then you can deploy that to other supported channels without writing any additional lines of code or without doing major changes in your implementation. You may have to do some configuration changes, but that's about it. Your core business logic or business implementation is going to remain same. Uh, And Power Virtual Agents has some inbuilt analytics that is available to you in the form of Power BI dashboard. That comes handy, especially if you want to find out how your virtual agent is doing, what kind of question your users are asking, and whether the bot is able to answer those questions or not. You'll also help get the information about customer satisfaction, the sessions as well. In the sessions, you can get the entire history of conversation between your virtual agent and your users. So let me show you a quick demonstration of the Power Virtual Agent. So for that, what I'll be doing is I'll be opening up, uh, let me share this window over here. Okay, so this is, even before that, if this is the first time you're seeing the Power Virtual Agent, I'm just search for it using Google or Bing. And this is the link that we're looking for. Just click sign in here. And once the page loads, then and after you sign in, and you will be redirected to this particular homepage. Now on this particular homepage, you will be seeing all the recent chatbots that you have created, or you can also create a new using this plus icon here. And when you click on a plus icon, you will see like two options. Build for production. This is the legacy designer that we have, uh, where it is currently generally available, and it is highly recommended for production. However, you can find a new unified canvas, which is under preview. But in this new unified canvas, you will be seeing some of the goodness that is there with Microsoft Bot Framework Composer are getting added to the Power Virtual Agent. So here, if you click on build for production, all you have to do is you have to give a name. Let's say Global AI Bootcamp London 23. Then you have to specify the language. So as you can see, these many languages are currently supported. Some of those are like 9 languages are in preview. So let's go ahead with English in this case, and then click create. So this particular operation will take 1 or 2 minutes. And this will be a good time to see if there are any questions that I can answer. So let me see. All right. Okay. Okay. All right. And typically, 1 or 2 minutes, your chatbot will be ready, and then this chatbot or virtual agents will be there without uh, any of your custom business logic, but it will have everything you need, so you can start adding your own customization in it. And as and when things will get ready, you will see the left-hand navigation. Those options will get available. Right now, everything is grayed out. Just wait for maybe 30 more seconds, and this page will automatically get refreshed, and then we can start exploring these options here. And also, you can anytime you can try this preview the new designer in preview mode. However, since it's preview, I don't recommend it for the production use. Okay, looks like our chatbot is ready. And here on this page, you'll see this one is a test bot. You can hide it once this page refreshed. Then I'll show you the other options here. Okay. So here, using this designer itself, you can create this chatbot and you can start testing it. If you don't want this, you can always hide this. And if you want this, then there is a test your bot button towards the bottom left corner. You can click on it and it will come back. And if you scroll down here, you will be seeing some information. Like for example, some of the tutorials that you can watch, and if you have any questions, you can ask that to the community. And if you have any comments for the Microsoft product group, you can share that with Idea Forum. Now let's talk about the topics. So by default, when you create a chatbot, it will come with some system topics. And the system topics, how you can know it's a system topic or not, those system topics will be always on. And it will also come up with some sample topics that you can use to get familiar yourself with how to implement a business logic. You can use those if you're not familiar with Power Virtual Agent, but once you get comfortable, my recommendation is turn those off. And here you can create a new topic. You can create a new topic from blank, or you can also use Bot Framework Composer to create the topics. If you go to a suggest topic, here you can specify a link, and from that link, you can get some predefined knowledge base and start using that within your chatbot. If you go to the entities, you'll see some predefined entities, but you can also create your own custom entities as well using this new entity button. Under analytics, you will see the analytics information about your bot. If you go to publish, this is where you can publish the bot. You can always change the name of the bot. You can change the icon. If you go to the settings under details, here you can see change the name. You can change the icon. Under channels, by default, when you launch your create the PVA bot for the first time, it is available on the website. But you can also make this bot available in other supported channels as well. Then if you would like to implement agent transfer, you can do that. Microsoft recommends Dynamics Omnichannel, but you can also use Customer Engagement Hub as well. When it comes to security, by default, there is no authentication available with a PVA chatbot, but you can use other options. For example, you can deploy this chatbot only for Teams, or if you would like to deploy this bot to additional channels, then you can use manual option. And under manual option, you have three options. You can either use Azure Active Directory Legacy, or you can use Azure Active Directory V2, or you can use generic OR2 provider. Since you can use generic OR2 provider, that means if you want to use any other external identity or authentication provider such as Google or Facebook, you can do that as long as that authentication provider follows a modern auth protocol. Then under AI capabilities, you can see here topic overlap detection is generally available, and topic suggestion from chat transcript is in preview, and conversational personalization is under preview. So before I know like I lost few minutes because of the technical difficulty. So let me do one thing real quick. I will show you an example of a chatbot I created, and this is just to showcase to you how we can implement some of the IT help desk scenario that most of the enterprises can use, and how a chatbot can act as a first line of defense. So once this chatbot loads, I will show you a topic real quick. And this is the topic that we have. And this topic gets starts whenever a user uses any of these trigger phrases. So what we essentially we are doing is we are helping the user whenever that user has an issue with the laptop or with the desktop. And then we ask them the series of questions, and depending on the answer, then we take a corrective measure. For example, if the user is stuck, then we are helping the user to create a ticket. And to create a ticket, we are using the combination of, we are using a Power Automate Cloudflow, and that Cloudflow will be helping us to create a ticket. So let me quickly show you like how this chatbot will look like in real action. Okay, I am having issues with my laptop. Okay. Did you reboot your machine? Because that's what the business logic we have added. We are asking series of questions. Did you reboot your machine? If the answer is yes, then we are asking like, hey, are you stuck? If the answer is yes, then instead of continuing the conversation with the chatbot, we are helping the user to create a ticket in our system. So if I click yes here, Are you stuck? Yes, I'm stuck. So now we are going to continue with the authentication. To create a ticket, what we would like to do is we would like to verify the user, and that's where I have added the authentication for this part. So if I go to the security section, but let me first finish this and then I will show you the security implementation. So I'll log in and this should launch another tab. Let me copy this code and paste it. And if the code is is the correct, then the chatbot will go ahead with the implementation. In the designer, I can see the testing in real time, and I can use this variable watch to see the values of different variables that I'm using. So this comes really handy, especially when you are debugging your implementation. All right. So now let me show you how exactly the security works. So if I go to the security, and if I go to the authentication, here I have used Azure AD V2 based authentication. And for that, I had to register an app in Azure AD, get its client ID, client secret, specify the scope, and then I can use that with as an authentication provider for my a chatbot. So this was a quick example. Let me quickly go back to my slides. Uh, these are some of the things like, as I mentioned, Power Automate is going to be your gateway to the outside world. And Power Automate has more than 600 connectors, and you can create your custom connector as well. These are the ways where you can implement authentication with Power Virtual Agent. You can go with Microsoft, Google, Facebook, or you can also use custom authentication provider. Now let's talk about Microsoft Bot Framework, because that's another way you can create custom chatbots. Microsoft Bot Framework is an open source framework that is available. You can use that to create custom chatbots. And using Microsoft Bot Framework, you will be creating your bot web service, and your bot web service will be continuously exchanging the messages with your users via different channels. And if you would like to implement intelligence in your bot, then you have to integrate your bot with something called Microsoft Cognitive Services. However, you can also use AI services from other vendors as well. And just like our Power Virtual Agent, most of the commonly used tools are supported. That that means once we deploy a bot, we can access that bot with supported channels or devices. And this is the typical life cycle that you will be following when you create a chatbot using bot framework. And to add intelligence to your chatbot, you need to integrate your chatbot with cognitive services. Here you can use either cognitive services or some of the latest OpenAI services that are part of Azure or OpenAI. Okay, you can also add Azure Communication Service in case you would like to add voice support to your chatbot that are built using bot framework. Azure Communication Service provides you voice and video calling, rich text chat, and SMS. So let me see if I can quickly show you a demonstration of Microsoft Bot Framework. If not, then I will just, let me see. Okay, let me quickly open a chatbot. Okay, and let's see if it's working or not. If it is working, I'll show you its implementation, and then okay, let me put this here. So this is the chatbot I created using Azure Bot Service, and I use C# as my programming language. So if I go to the channels here, so right now this chatbot is connected like available on web chat and also available on Microsoft Teams. But if you scroll down, these many channels are supported here. And since I use Microsoft Bot framework, I can go here and download the bot source code. Uh, like whatever the source code I have used, I have the copy of it, so I can just download and start implementing changes in it. Because of time limitation, I would like to cover a few topics, and if I am done with that, then I will be like going back and show you a quick demonstration of how you can do this from a scratch. But before that, I would like to cover a few points which are very, very important, especially if you are planning to implement virtual agents or chatbots within your organization. So since the idea behind any chatbot is to mimic the human conversation, you want to use AI services as much as possible. And when it comes to launching a virtual agent, you would like to make sure you're setting the clear cut expectation related to the AI. Like, when it comes to AI, with all the hype around Chat GPT and OpenAI, a lot of people's expectations have increased a lot. But you need to make sure you are explicitly telling like what this your virtual agent is capable of doing and what is not going to do for your user. Start slow. Virtual agent or chatbot implementation is still fairly new as compared to traditional web development or mobile app development. So start slow and try to address a few use cases first, and then use the lessons learned from that, and then try to add additional features in your bot. And analytics is very, very important for continuous improvement, and use telemetry to gain business insights and improve your bot's performance. And always have a capability to transfer control to a human agent. You don't want your users to get frustrated, especially if the bot is not helping them. You want some kind of mechanism where you're escalating to actual human agent. Now, depending on your organization, you may use some sophisticated tools such as omni-channel. But let's say because of some budget, you cannot use that. You can also help the user to create a ticket in your ticketing system, or you can also do a simple courtesy thing that you can summarize the problem user is having, and maybe you sending the email on the behalf of user to your help desk. And that you can do using the combination of Power Automate or from your Power Virtual Agent. Or if you're using with Bot Framework, you can use any of the service over there. You can use Azure Function, or you can use Logic App, or even Power Automate. And it's all very important that you have fusion of tools and skills, because fusion teams, majority of the organizations are having fusion teams, and it's extremely important that you have a team, a fusion team over there, so that you have a professional developers and domain expert, and they are working together to create a meaningful chatbot for your organization. I always say this, like it doesn't matter what kind of tool or technology you're using, whether you're using, let's say, Power Virtual Agent, Microsoft Bot Framework, or you're using product for other third-party company. The what kind of problem you're trying to solve matters a lot. So with that, let me quickly show you a quick demonstration of this. So let me go to language service, Cognate Language Studio. Okay. And once it's load, okay, there is a question. Could you explain or outline the steps that I will need to integrate PVA chatbot into my website? Okay, so good question. Let me go here and let me show that to you real quick. So let's say this is the chatbot I have created. If I go to the channels section here, then your chatbot is by default available on a demo website. You can always share that URL with your other testers or other users. However, Microsoft recommend that you don't use this as your production instance. And let's say if you would like to add this chatbot on your React website, all you have to do is click on this custom website. And here, then you will get this iframe. So using this iframe format, iframe, you can just inject this chatbot into any of your website, whether it built with React or any of the supporting technology, as long as your website allows you to inject iframes in it. Okay, let me quickly sign in. But that was a good question, Amir. Okay. Okay, let me see if I have a resource or not. Perfect. Okay, done. Okay, we have this question answers. And let's scroll down. Okay, so this is not the one I was looking for. Okay, let's go here. Let's go to your Azure portal, portal.azure.com. And what we do is we will be just quickly create a chatbot and register that using Azure bot service. Okay, let's click on create resource. Okay. Okay, let's go with Azure bot. Click create. And then let's select a bot handle. So I'm just going to go, let's say global AI boot camp London 2023. So I'm just going to go ahead with this one. And the resource group is going to be Azure Workshop. Pricing, I'm going to go with standard, but if you change here, you have other pricing tiers as well. So you can also go ahead with the free tier, especially if you're doing a quick POC. I don't know why Microsoft always select by default as S1. So I'm going to go ahead with free and the type of app and everything I just create and just click review and create. Okay, and then create. Okay, so now it is deploying our bot using Azure bot service. However, it will be a vanilla bot. That means it will not have anything in it. It just like it will have a structure. But after that, then we had to build our a business logic inside it. Okay, let's go to the resource. Okay, now let's go to the channels here. So by default, this particular bot is available on direct line and web chat, but you can also add the support for following supported channels as well. Then here, if I go to the bot profile, I can add, like, change its display name. However, it's a handle. I cannot change that. I can upload the icon. And the next thing I was trying to go here is, okay. Okay, here we'll see some samples regarding the bot framework and other stuff. So I think we are coming close. So let me cover a few more slides, and then we will see if there are any questions there or not. So in case you would like to get your hands dirty, there are two ways you can get access to, uh, like, okay, let me remove this and move this over here. Okay, let me enable this slide. Okay, okay. So if you would like to get your hands dirty with Power Virtual Agent, what I recommend to you is go to this website or search for Microsoft 365 Developer Program. And on this, once you go to this link, you can sign up for the program, and it's a free program. Once you sign up, you will get an email, and you can provision your own Microsoft 365 developer tenant. Using that tenant, you get access to Microsoft 365 services with E5 licenses such as Exchange Online, Shepherd Online, Teams. It also comes with Power Platform, such as Power Apps, Power Automate, and you can also sign up for free trial for Power Virtual Agents. So that way you can try Power Virtual Agent for free, and this will be your dedicated sandbox environment. And as long as you don't violate the licensing terms, you can use it for a pretty long time. In case you would like to get your hands dirty with Azure, then these are the ways where you can get your personalized subscription. My personal favorite is, if you have access to MSDN, definitely go to your MSDN portal, activate your monthly credits, and use that for your training. You can always sign up for free trial, but when you do, you have to provide a credit card. There's a third program called Azure for Students, where you don't need a credit card. All you need is a valid EDU account. And depending on your country, you get some fixed credit. So hopefully, the content we covered today made you explore Power Virtual Agents, Azure Communication Service, and Bot Framework. And these are the things we covered today. And these are my contact details. If you have any follow-up questions, feel free to reach out to me. I'm available on uh, LinkedIn. I'm available on. Okay, so Mir is asking, what is the main difference between an Azure bot and Power Virtual Agent bot? So let me see. I have a slide for that, and since we have 2 minutes left, I'm just gonna cover that. Okay. Let's see. Okay. Unhide and okay. So one of the things you have to keep in mind is Power Virtual Agent is a SaaS product. That means it's a licensed product. Everything, like, you don't have to worry about where to host your bot. All you have to worry about is configuring its user experience, and anyone can use it. It has inbuilt support for analytics, but it is a little bit expensive to begin with. However, if you go with Microsoft Bot Framework or Azure Bot Service, there is a steep learning curve. You need to be a developer. You need to be either familiar with C# or Node.js. And by out of the box, your bot will not be an intelligent bot. You have to integrate that with other AI services. And then there is no inbuilt support for analytics. You have to add that yourself. So if you go with Microsoft Bot Framework, it will be a little bit inexpensive to begin with. However, you need to add or consider like other additional charges as well. Like, for example, you need a service to host your bot. You need app insights. You need search. You need other cognitive services. So eventually, it may happen that your cost with PBA and Microsoft Bot Framework is quite identical. And if you see the roadmap from Microsoft, they are recommending that to use Power Virtual Agents as your first choice. And if for some reason you cannot use Power Virtual Agent, then only use Microsoft Bot Framework. All right, with that, we come to an end. Please let me know if you have any follow-up questions. And what I will do is I'll quickly show my contact details. But with that, I really would like to thank the organizers for giving me an opportunity to speak here, and also for you, even though I had some technical difficulties, still sticking up with my talk here. So with that, thanks for joining us. Stay safe and stay healthy, and let me know if you have any follow-up questions.
Thank you, Prashant. That was really good. I enjoyed that. Yeah, so if you have any more questions, yeah, please do follow the LinkedIn and email. But if not, yeah, thank you very much. And we'll hopefully join you on the closing on the Johnny 5 channel.
All right. Thanks, everyone. Bye-bye.
Thank you. Right. So thank you. I hope you have enjoyed the talks today. There has been some releases of Git repos on the chat throughout the day since people have requested some of the code. They are available there. And yeah, I've really enjoyed these ones. And I am about to move over to the Johnny 5 channel because we are going to have a closing remark from the team. So thank you all for tuning in, and I hope to see you soon. Take care.